Welcome to this module on Python. So if you've never used Python before or even heard of Python before, Python is a coding and scripting language. It is commonly used in ethical hacking, and it's commonly used all around the world. It is actually considered one of the best beginner languages to start with if you've never learned coding before. So that's exactly what we're going to do. We're going to cover some of the basics of Python. So we'll cover everything you see on this screen here: strings, math, functions. We're going to get into conditional statements and looping. We'll get into some more advanced items, and eventually we're going to build our own tools. So we're going to be building a port scanner at the end of the lesson. And then when we get into the exploit development section of this course, we're going to use Python again to write our own exploits. So it's going to be used throughout the course. You're going to see it again as a ethical hacker as well. You're going to go on to websites and you might need to download Python code or something to utilize against a host or a client, and it's just going to be frequently seen for you. So very important topic to cover, especially for the foundations. One very big thing to point out: you do not have to be a developer to be successful in penetration testing. The important thing is that you understand what you're seeing and understand how to read code. If when you come away from this module, you have a better understanding on how to read what you are seeing in code, you'll be much better off. By no means do you have to be a developer. I am still to this day nowhere near a developer level, and I'm very, very successful in what I do. You don't have to be a developer. So the big takeaway here is to take very good notes, understand what you're seeing. If you need to watch a video multiple times in this section, absolutely okay. Just make sure you understand everything in front of you and understand that the lessons are going to build upon each other, and it should all come together in the end. And you're going to get to see it over and over through the course, especially in the exploit development section where we write our own Python script. So I look forward to teaching you this module on Python and look forward to seeing you in the next video. Welcome to your first video on Python. So in this Python series, we're going to cover a lot of different topics, and we're just going to build upon them slowly so that everything builds kind of upon the last lesson. So in this first lesson, we're going to be talking about strings, and we're going to be working primarily in Python 3. So quick thing to note is that my Kali interface might look a little bit different. I'm on my personal pen test machine here. The only reason I'm doing that is because when we get into the text editor, my text editor on the newer version of Kali would not let me edit my preferences very easily. So I went ahead and just went back to my machine that has an older text editor on it. So you can follow along completely step by step in your Kali and you should be fine. I just wanted to make sure that the font size is good enough for the recording. So from here, let's go ahead and make a new directory. And I'm just going to call this directory Python. And then we're going to change directory into Python. And the first thing we're going to do is we're going to gedit, and I'm just going to call this first.py. This will be our first Python script, and we're going to build on it. So the first thing we need to do is declare what it's called a shebang. So that is a hash bang like this. And we're just going to declare bin python3 here at the top. Now, what does this do? This allows us to know, or the Linux to know, when we run this. Say we were to run this like Python 3, and then we just say first.py. If we run it like this, then Python interprets the hash here, which you're going to learn in a little bit, as a comment. So all of this is commented out. We don't have to worry about it. But let's say we wanted to run this a different way. We wanted to say /first.py. Then it would actually be interpreted here at the top. So Linux would go in here, it would read this, it would say, hey, this, I'm going to go ahead and look for bin python3. It's going to find python3 in bin because that's where it's stored. And then it's going to use that to execute Python, or this Python script here. So we have two ways of running it. We could either run it python3 first.py, or we can run it as you've seen it with some of our other scripts with the / like this. So I always like to declare at the top. It's not necessary if you're just going to type in Python 3, but I always like to do it. So I'm going to give you some headers here. So I'm just going to put a comment in, and we're just going to say print string. And so the first thing we're going to do is print a string. Now, in the very stereotypical lesson, the very first string that most people print is the hello world. So we're going to go ahead and just do that. So let's go ahead and print hello world. And we're going to do that by just typing in print. And then in parentheses with quotation, we're going to say hello world. Something like this. Okay. And that's it. So what we can do here is we can just save this. And we can go ahead and give this a go. So what we'll do is we'll say Python 3, and then we could say first, and it'll auto tab out to first.py. And you can see now that it wrote out hello world. So if we go tab up twice and go back to our gedit, we could see here that it ignored printing out anything here with the comment. It didn't interpret this because this is a comment with the hash. And we just told it one instruction, which was to print hello world, and it did just that. So the nice thing about strings is we could use double quotes, or we could use single quotes. So we could say, sorry, hello world like this. And we can also use multi-line strings. So I'm going to tab or hit enter twice here, and we could say something along the lines of print. And what if we have like a long quote? We could say something like, this string runs, and then we could say multiple lines, like this. And we just put that with triple quotations like this. And lastly, we can do a little bit of what is called concatenation. We could say something like print this string is, and then we'll want to put a space at the end here and end the quotation. Then we could put a plus sign in here, and we could say something like awesome and end that parentheses. So with all of this, you're going to see that, okay, we can print hello world. It should print hello world, this string runs multiple lines, and this string is awesome. And it should be space awesome here because we included the space. Now you're going to notice, even though we put line breaks in for us, no line breaks are going to be printed. We'll talk about that here in 1 second. So let's save this and let's just run it. So we're going to go ahead and run Python 3 first.py, and everything looks as anticipated, right? So I want to show you one thing. Let's tab up twice, and let's put an ampersand at the end of this. Watch what this does. Now, we have access not only to our script here, but we can also run code as well. So as long as we save this, we can run the code, and we don't have to keep exiting out back and forth. So let's say that we did want to put a line in between these two hello worlds. We've got this here. What we can do is we can print this. Can say something like a N like this, if I could type today, and we close this off. And you could put a little note next to it so you remember, and just say new line. So when you have that \n, that prints out a new line. So let's save that and just take a look at that. And there you go, you have a new line put in there. So quick and easy way to add a line in or a line break. And yeah, so here, very simple lesson, right? All we're doing is just learning how to print things, and we're dealing with strings. So even if you want to go in and build upon this, you can add comments in for yourself to make this easier. So you can come in here and say double quotes, you could say single quotes, and then you can come in here and say triple quote for multi-line. Right? And this way, you know kind of what everything is doing. This one you can say here, you could say, we can also concatenate. I don't know if you spelled that correctly, but I'm hoping I did. So that's really it for this lesson. Just wanted to cover the basics. So in the next lesson, we're going to start talking about math and the math that Python can do. And again, we're just going to continue to build upon this. So I'll catch you over in the next lesson. All right, let's talk math. So the nice thing about Python is that right off the bat, it has a built-in math interpreter. So what we can use it for is addition, subtraction, multiplication, division, etc. We could throw numbers at it and it'll do calculations for us. So let's take a look at what that actually looks like. So I'm going to go ahead and gedit. We'll call this math.py. You can call this whatever you'd like, by the way. I'm going to put the ampersand at the end again. And we'll just declare our bin Python 3 here. And then let's just call this math. So the nice thing about math is we can do a lot of different things. We're very flexible. So for example, we can print 50 plus 50. And here we're just adding, right? So let's take a look at what this looks like. We go here and we just say Python 3 math.py. You can see that it prints out 100. Now we can keep doing this for all sorts of different things, right? We can do 50 minus 50. We would expect 0 here, right? And we can do print 50 times 50. And we can also do print 50 divided by 50 and divide. So I'm going to give you a chance to catch up here. I typed that very fast. I also have notes that I'm looking at, so a little bit of unfair advantage. But so when we see these and we save this and we run it, we're expecting everything to interpret just the way it did. So you see 100, 0, 2500, and then this 1.0, which we'll get into in just a little bit as to why it's coming out in a 1.0 format. But so we have this here, and we can also do some interesting things, like let's do something fun. Let's do print 50 plus 50 minus 50 times 50 and divide by 50. And what do you think this is going to do? Our good old friend of PEMDAS, if you remember that from math class. So try it one more time, see what number it pops out. Pops out 50. So it also does more complex equations as well. So there's a few other things that I want to show you in the math section. And another thing to note, I know I've already stressed this before and I'm going to keep stressing it, is to make sure you take good notes. This is absolutely going to feel overwhelming. I'm going to throw a lot of things at you, especially with all the stuff that you're learning. Take good notes. Have a good notebook and make sure you're writing this all down so then you can just go back and you can reference it. And from here on out, the next video, what we're going to do is we're going to make a script and we're just going to build upon it, and I'll just leave everything in that script so that way you kind of have a place for all of your notes as well. So here, let's talk a couple more things. So we can also do exponents. So let's say we want to do 50 to the 50th power. Well, we just write it like this. And now we have exponents here. Save it, run it really quick. And we get this very, very, very large number, right? We could just make this to the second power and make it a little bit simpler. We could also do this. So we do print and we do 50% 6. Now this is called a modulo. Let's take a look at what it does. So 50 is not divisible by 6, right? So what it does is it takes the number that is left over. So we do 50 divisible by 6. Okay, 6 goes into it 8 times, and then it has a leftover number of 2, right? 6 times 8 is 48. Leftover number of 2. So that's the modulo. What if we were to divide by a number here, and we said 50 divided by 6? What is that going to do to us? Well, we print that out, and you see it gives 8.33334. Perfect, that's fine. What if we just want a number without any leftovers? Well, we can do something like this. We can do 50 divided by 6, and then we'll just say no leftovers here. Okay, so I'm gonna give you a second to catch up. We'll hit save on this. and we're going to go ahead and run it. And you can see that it just gives us the 8, doesn't give us that leftover of 2 that we had and put it into fraction form here, or decimal form here. So we have different ways that we can manipulate these numbers, and we can do math on the fly. There's also math modules, which we haven't gotten to the modules yet, but there are additional math items that we can pull into this, like bringing in random numbers, for example, and other things that we can do more advanced calculations in Python. But as a base, it does quite a bit of items for us, and it is essentially a built-in calculator, so we can do quick math on the fly if we need to. So let's go ahead, and from here, we're going to move on to the next video where we're going to start talking about variables and methods. All right, so let's talk about variables and methods. So to do this, we're going to make a new file. So let's do gedit, and we're going to call this one script.py, because in the last video I told you we're just going to start building off of these scripts, and we're just going to keep it in one script and keep it going. So let's gedit script.py. We'll do one more shebang here of bin python 3, and then we're going to go ahead and just build this out. I'm going to drag this over just a little bit. So let's put another comment up here, and we'll just call this variables and methods. And let's define a variable. So let me show you what a variable looks like, and then we'll define what a variable really is. So let's start with a quote, and you can pick your favorite quote here, and we're just going to say something like, "All is fair in love and war." Okay, so what's happening here is we are creating a variable of quote. Now, a variable, all you can think of a variable is as a placeholder. So instead of typing out "all is fair in love and war," we can just call this placeholder at a later time, and it knows, hey, I'm going to call this information. So it's going to store this information inside of quote, and then later we just call quote, and it'll print it out. So we can do something like print quote and save this, and I forgot to ampersand, so excuse me, we're going to close it, and let's just run script.py, sorry, python 3 script.py. You can see it says all is fair in love and war. So if we gedit this and add the ampersand now, so we defined what was in our variable here, which was this string, right? We've talked about strings. We put a string here as our quote, and we printed the quote. So if we didn't put the print in here, we can copy this and just delete it. If we save this and we go to print this now, there's nothing telling this to print. So we have quote, and we have a quote stored in our quote variable, but nothing instructing it to print. So we can leave the print back in there, just copy and paste it back, and now it'll print that quote. Now we also have what are called methods. Okay, so methods are basically functions that are available for a given object. Okay, so don't worry too much about that description. That's very dictionary-based description. Just think about what a method does. So I'll show you these methods here. So a method might look something like print quote, and then let's say we want to make quote upper. So in order to make it uppercase, all uppercase, we're just going to throw in this method of upper. So we just say dot upper. And if we were to save that and print it, look, now the text is all uppercase. And you can make a note in here if you want and just say makes it uppercase. And we can copy this. Let's just copy this whole line like this. And let's paste a couple here. So we could also do something like lower for lowercase. Or we can do something like title for title case. And we can make notes here of lowercase and title case. Okay, and we save that, and when you print it, what do you think is going to happen here? So we're going to say, all is fair in love and war, all is fair in love and war. And you can see in title case, not perfect. It's capitalizing the and here and the in and the is. but it does capitalize every first letter as it's instructed to do here. So these are methods. There's also other things that we can do. We can do something like, say we want to get the length of this quote. We want to know how many characters are inside the quote. We can do something like print length of quote. Okay, and we can just say save, and let's see what it prints out. Okay, so 28. Now it's 28 characters completely. If we were to count this all up, including the spaces, there's 28 characters there. So let's make this a little bit more interesting, and let's talk a little bit more about math and bring that into it and try to tie this all together with what we've learned so far. So let's use your name. Let's define a variable of your name, and we're going to set it as a string. So my name is Heath. So we'll just say this is a string, right? And let's also define your age. Now I'm 30. And we'll say this is what is called an int, or an integer. Okay, and let's say, what's your grade point average? And my grade point average was 3.7. And this is what is called a float. Now, what is the difference between an integer and a float? Well, an integer has no decimal point. A float does. So if I was 30 years and 27 days, I might be 30.1 years old, right? But if I only define as an integer, if I say int 30, then that's going to define that this number is an integer and nothing else. Same thing with float. If we want to have the decimal point there, we can float a number and define it as like 3.7. So let's make more sense of this. We can print out the integer of my age, and we can also print out the integer of my, or we could say 30.1, and let's see what happens as we discussed here. So let's save this, and let's just print out those two. And look, it takes 30.1 and makes it 30, and it takes integer of age and makes it 30 as well. Now what if this is 30.9? What do you think is going to happen? Do you think it's going to round? It in fact does not round. So you could see 30.9 still came out to 30 down here. It doesn't matter, it just takes this first number when we call an integer. So make sure that if you ever use integer, you know that it does not round. So let's build upon this again. We could take a string now, and let's print out a string. We could say something like, my name is, and then you could say plus name. Make sure you add the space in there, right? And you can also say space, and I am space. And then let's define an age. So if we try to put age in here, watch what happens. So we're going to say age, and we'll say space years old. And let's save this here like this, and I'll give you a second to catch up. So again, we're adding a space in the beginning, space at the end here, just so that we have the syntax right, or else it's going to all bunch up together. So let's try to print this out. And you could see cannot concatenate a string, not integer to string. So this age here is sitting here as an integer. You can't concatenate a string with an integer. So how do we fix that? Well, what we can do here is we can actually put this into a string format. So we'll just say string of age, something like this, and save it, and now it makes it to a string. So similar as we made something into an integer, and how we can make something into a float, we can also make something into a string. So if we come through here, and we hit enter, you can see now that it works. My name is Heath, and I am 30 years old. So a couple more things to note. What if we had something like our age, and we got a year older? Well, we can just say something like age plus equals 1, and we could say print our age. Now watch what happens. Age is now 31. Even up until that point, age has been 30, right? You see age coming through here. We're utilizing it in all three places. Now we print age down here and it's 31 because we have changed what is stored in the variable. So again, the variable here of age, we had 30 stored in it. Up until the instruction is called to add 1 plus equals 1, so we're just adding 1 to this age variable here, then it stays 30. Now it is 31 until we change it again. So we can also do something along the lines of birthday equals 1. So we have a value of birthday. And then we could say age plus equals birthday. And then you're going to print your age again. And guess how old we're going to be? We are going to be 32. So it doesn't matter how you store it. You can do the plus equals here or minus equals if you wanted to take away. And you can start incorporating your math into your variables. You can incorporate your variables into your strings, and you can start tying this all together. So if you need to rewatch this and to make more sense of it, that's absolutely fine. I'm going to harp one more time on this. Take good notes. Practice, practice, practice. This is stuff that can get overwhelming very quick, but hopefully I'm explaining it slow enough and you're getting it. If you're not getting it, please do rewatch the video, please take notes, and please utilize outside resources as well. I understand that I might not always be the best at teaching a particular subject, or sometimes it takes another person hearing it again from somebody else to see this. Coding is not necessarily easy, but once it clicks, and a lot of it is just repetition. So that is it for this video. We've started to tie everything together. Now from here, we're going to move into what are called functions and build upon all of this. So I'll catch you over in the next video on functions. All right, let's talk about functions. Now, functions are what I like to think of as mini programs. It's like this organized block of code that you define and then you can call it later, and it makes it a lot simpler than typing everything out. So it's a lot easier to visualize this than me to just talk the theory of it. So let's go ahead and let's gedit our script again, our script.py, and then we're going to ampersand this one this time. And we should have our Python script from before. I'm just going to scroll down to the bottom and I'm going to add in a new section here, and that section is just going to be called functions. So if we want to print out, we can print out a new line to kind of put this together. And then maybe when it's all said and done, we can print a function or make a function that just prints and make it a little bit easier for us. So we're going to print a new line here, define functions, and maybe we'll just print out something that says, here is an example function. So this is really just going to define the area. If we save it, while you're typing yours, I'm just going to print mine. So we'll python3 script.py, and you see we've got the new line here, and we see here is an example function, and we just start from here. So let's take a look at a function using something that we've already done before. So we've got this section here, and we've got name, age, GPA. We're going to kind of reuse this in this print my name is. So let's go ahead and reuse this. We're going to say function here, right? So we're going to define kind of a who am I. So we're going to define this, and then we're going to do 2 parentheses and then a colon here. So it's going to look like this. And what's important now is that we use indentation. Now we haven't had to talk about indentation to this point, but Python is very, very critical on utilizing indentation. If you don't use it in the right places, then your program will not function. So it's very important to know when to use indentation and to indent properly. So to indent, I'm just going to tab here, and I'm going to redefine everything again. So we can just say name equals Heath, and we can just say age equals 30. Type that wrong there. And then we can just copy this print right here. So we don't have to type it all out again. Just copy and paste it. And you can see define who am I, and we're going to define in this function a name variable, an age variable, and then we're going to print this out. So if we were to just go ahead and save this and print this, nothing's here. All we've done so far is just define this function. We have done nothing to actually call it or do anything. And let's make a note here that this is a function, right? So when we get down towards the bottom, let's go ahead and just try to call this function. So to call a function, all we got to say is, who am I? And let's go ahead and save this, run it again. And look, it says, my name is Heath and I am 30 years old. Well, what's happening here? Okay, so we're defining a set of things to do, right? This is a mini program. And inside this mini program, we've defined our variables and we defined an action here to take, which is printing out this string. So what it's doing is when we call this, it's saying, hey, I'm going to go ahead and take all this and I'm going to run this program and give you the result. Now, what's important to note is whatever is stored in these variables here is only stored there inside the function. If we were to print age from the last video, it should still be 32, I do believe. So let's print and you'll see it's 32. Even though we declared age up here as 30, that only lives inside this function. So I'm going to go ahead and delete this. So again, everything is living inside this function and it's a mini little program that we have here and we just call it at a later time. So let's go ahead and build out another function and we can kind of start to make sense of this. So let's start with adding what are called parameters, and we'll just do adding parameters here. So let's make a function, and this function is called add 100, like this. Okay, and then the parameter I'm going to actually add inside, instead of giving empty parentheses, I'm going to add in something called num. It's just going to be for number. And then we're going to go ahead and use our colon, hit enter, do a tab, and then what I want to do is I want to print number plus 100. So what am I doing here? I'm taking a number and I'm adding 100 to it. So my function of adding 100 makes logical sense. Okay, so what's going to happen then if I say add 100 and then I specify a number in the parameter? Well, I'm going to say, what if I want to add 100 to 100? Well, then I should, in theory, print out 200, right? And there you go. We have successfully printed out 200. So we can build upon this even more. So what if we want to use multiple parameters? Okay, let's say we want to, let's do multiple parameters. And we want to define an add function. We're just going to make an add. Even though it's built into Python, we're going to make our own. So we're just going to say add x and y. So now we have two parameters here. Okay, we're going to add our colon, make sure we indent, and then we're just going to say print x plus y. Now, if we go in and we add 7 and 7, we should get 14. And there's 14. So hopefully this is starting to make sense. All we're doing is building these mini programs, and we can have no parameters, as we saw up here. We can have single parameters or multiple parameters, depending on what we need. So let's go ahead and build a couple more out just to make sense of it. So what if we wanted to define multiply? And we'll just say xy again. What do you think that's going to look like? Well, instead of saying print, what if we say return? I'm going to throw something new at you. I'm going to say return x and y. Okay. Now, what happens if I call multiply and I say 7, 7 again? What happens here? Let's go ahead and save it. Well, nothing happened. we're not printing out to the screen. All we're doing is returning. So when I'm pulling this multiply in, it's returning a certain number. So I'm calling it here, and it's saying, hey, 7 times 7, that's 49, but I have no idea what you want me to do with it. Now, I could say print multiply here, and then we can see what happens. And now you see it's 49. So the return feature just allows us to return the number that is back to us, right? We don't have to always print it out if we don't want to. We can store it for later. So that's what we can do here. So we don't always have to print it. We can return the number and then call it later. So that's one way of looking at it. Let's do one more. How about we define square root? And we only take one number here. So how would we do the square root of something? Well, let's go ahead and just print out x. And then we're going to do by 0.5. Remember the exponent with 2 multiplications here. And then we're doing the square root, so we're going to take 0.5 instead of squared, which would be 2, right? So we're taking the square root, do 0.5. And let's take an easy one. Let's return the square root of 64. So let's say square root of 64 and see what happens. And it returns 8 for us. Now we can make that an integer if we want to and go from there. But that's just a nice base example. So lastly, I mentioned that we can make a function for a new line because we've been sitting in here and we've been just typing print, and I am slow at it. I have to sit here and think about it, and then I find the correct letters, and this is how you print new line. Okay, I'm not the best at it, but what if instead we just did something like define new line, and then we just put this here. So then we can just call a new line from here on out. We could say new line, and then when this prints, it'll print out a new line. And while it's the same kind of length-ish of this, we don't have to type in these special characters, look for them. We could even shorten this to like NL, something like NL, and then make it really simple. And then we save time. And this is where these programs come in and they save time. So good example of a use of a function. So I'm going to save this. If you want to use this for moving forward and going on in the next videos, absolutely welcome to. So if you're following along, go ahead and just leave your text editor open, and I will catch you over in the next video as we start to talk about Boolean expressions. Welcome back. So now we're going to discuss what are called Boolean expressions. And we can go ahead and just type this right into our text file. If you don't have your file open with gedit, go ahead and get your script.py open. And what we're going to do is we're going to just put in here Boolean expressions. And now when we say Boolean expressions, we can just think of this as true or false. So let's go ahead and print our new subject line. We're just going to call these Boolean expressions. And from here, let's start defining those. So let's say we have Boolean expression 1. We'll just call the variable bool1. Now let's just set that equal to true. Okay. And let's give an example of that as well. Let's just say boolean2 equals, let's say 3 times 3. Now, what does 3 times 3 equals? Well, that equals 9. So we can say equals equals to mean something equals something. And so this number equals this number. So 3 times 3 is 9, which equals 9. So if we take this expression and we say 9 equals 9, it's going to return true. Let's do a couple more. So we could say boolean 3 equals false, and boolean 4 equals 3 times 3, and then we can say does not equal 9. Well, that's not true, right? So that's false. So if we were to print these all out, we could say print boolean 1, boolean 2, bool 3, and bool 4. Okay, and let's also print the type so we know about this. So we say print type, and let's take a look at what this looks like. So once you have that all written out, go ahead and just save this. And go ahead and run your file. And you can see that it came out exactly how we thought it would. So we've got 4 variables, and they're all Boolean expressions, right? So we've got true, this equals to true, this is false, and this is equal to false. So we see true, true, false, false when we print those all out. And then when we want to look at the type of the variable, so we say, hey, what's stored in here? Inside this variable, what's stored is a Boolean. Now, please do note that there is a difference between true and true. One is a string and one is a Boolean. So if you were to set Boolean 5, for example, to true, and then you printed the type of Boolean 5, then you're going to get a different result here. You're going to see now that the type is a class of string. So big difference here. I'm going to go ahead and just delete this. So this is just an overview of Boolean expressions. We're going to use this later on, and you will see it again when we get into exploit development, but you're going to see certain things, especially when we get into loops as well. So once we start getting into looping and we talk about that, it'll make a little bit more sense. But you want to know sometimes if something is true or something is false. Or when we get into conditional statements, if something is true, then do this. Or if something is false, do this. We haven't gotten quite that far yet, but we need to introduce the concepts before we can build upon it. So what we're going to do in the next video is we're going to build upon these even more. We're going to take relational operators and these Boolean expressions and kind of combine them and start building upon it. And then once we get this all put together, it'll all start making sense. So for now, all you need to know is when I say Boolean expression, all I'm thinking about is true or false. So we'll build upon that in later videos. Okay, let's build upon where we just left off with the Boolean expressions. So now let's talk about relational operators and Boolean operators. So what do we mean when we say operator? Let's go ahead and just add a new section here, and we'll just say relational and Boolean operators. If you want, you can go ahead and just put a new line here. So remember, we specify a new line in a function. And let's say greater than. Let's define a variable called greater than. And let's just make that equal to 7 is greater than 5. Okay, so we're using a operator here with the greater than symbol, right? And we're also using a Boolean expression because when we say 7 is greater than 5, well, that's going to come back with true. And we could say less than. We could say 5 is less than 7. And that's also going to return true. What about greater than or equal to? We can say 7 is greater than or equal to 7. And that's going to return true as well. And then if you can think of less than or equal to, it's going to be very similar. We say 7 less than or equal to 7, and that's also going to be true. So if we were to print all of these out, which we don't have to, they're all going to return back true. So there's other things that we can add in here. So what if we bring in multiple operators? For example, we could say test, and you can call this whatever you want. So what if we say 7 is greater than 5 and 5 is less than 7. So we see here that this is true and this is true. That would make this entire statement true. So we could say true here. If we were to say, let's just call this test and 2, we were to say 7 is greater than 5, which is true, and 5 is greater than 7, well, that's not true, so this whole statement is going to be false, because we're going to say and. And is very important here, right? What if we were to say something like or, though? If we were to say, let's test out or, we could say 7 is greater than 5, or 5 is less than 7. Well, this is going to return true. And if we were to do the same thing as we did above, where we say test or 2, and we say 7 is greater than 5, or 5 is greater than 7. I forgot my parentheses here. And this is also going to return true. Why? Because only one statement has to be true here for these both to be true. In the instance of and, both statements here have to be true in order for it to be true. If one of them becomes false, the whole thing becomes false. In the sense of or the case of or, if both are true, it's true. If one or the other is true, then it's true. Both have to be false for it to actually return false. Okay? So you can print these out as well to test this out. The other thing that we can say is we could say something like test not. We can say something like not true. And guess what not true is going to be? False. And if we said not false, then that'll be true. So these are the ones that can start to kind of get confusing. So again, my recommendation is to make good notes on this and then go out and study it. And there are true-false charts. Let's just see if we can Google one quickly. There are true-false charts online. We could say true-false chart Python. And go to images. And we can see truth tables is what they're called. So if A is true and B is true, the A and B are true. If A is false or true and B is false, then they're both false. False true is false and false false is false. So in order to have a truth table for and, everything has to be true. So if we search truth tables, that might give us a better chart here. And then you get something sort of like this, where you have and, where you see true, true is true. You have or, where true, false is still true. And then XOR we don't have to worry about right now. So take good notes on these. Make sure you understand them. We're going to continue to build upon them over time. Really, all you have to think about, though, is you have to think about Boolean operators and these expressions. And the most important things to take away from this are not just the true and false, but the greater than symbols, the less than symbols, all these different types of operators that we can utilize here. And that we can also utilize things such as and, or, and not as well. So we're just adding more tools to our toolkit and more things to think about. Where Python is important when it comes to pen testing is not necessarily being able to develop. And I've said this before, I'm going to say it again. Being able to read and understand what is going on is super important. Being a developer, not as important. So as long as you see these things and you see a true, or you see a statement like this when you're reading code, and you say, hey, I know that's a Boolean operator. I know it's true or false, and I kind of understand the truth tables, right? So that's really what we're after here. So as long as you start getting this understanding and this comprehension, that's really what we're after. So from here, we're going to move on, and we're going to go into conditional statements, and that is where we get into something called if, then, else, and we'll have a little bit of fun with those. So I will catch you over in the next video. Now we're moving on to conditional statements. Now you could think of conditional statements as an if-else scenario. For example, if you go to the store and you want to purchase a drink, and the drink cost $2. Well, if you have $2, you're going to be able to purchase that drink. If you don't have $2, then you won't be able to purchase that drink. That is a condition. So the condition there is based on the amount of money you have. We can take these conditional statements and we can run if else. We could also run if else, and build upon these. Now it'll all make sense when we start putting it together in our script here. So let's go ahead and just do that. Let's make a new line. And let's make a comment here that says conditional statements. And let's start with a conditional statement. So a conditional statement's going to start off looking like a function. So we'll say define. And here, let's make the same scenario where we talked about the money and buying a drink. So we'll define drink, and we'll just say a parameter here of money. Okay, and then let's indent, and let's say if money is greater than or equal to 2, remember we talked about $2 for this drink, then we're going to return you've got yourself a drink. Now, what if we don't have the money? So we could say else, if our money is not greater than or equal to 2, then we're just going to return no drink for you. Didn't mean to capitalize the O there, but I'm leaving it because I like it. So in this situation, we have our conditions set. Now again, if our money equals or is equal to or greater than 2, we're going to get a drink. And if not, we're not going to get a drink. So it could be anything else, right? So what we can do now is, since this is just returning and not printing anything, we can print out something like drink, and then we specified the amount. So if we have 3, we should return one thing, and if we print drink here with only $1, we should return another. So let's go ahead and save this script. And I didn't put this with an ampersand, so I'm going to close out and make sure I do that next time. And what we're going to do is we're just going to go ahead and python3 script.py. And you can see down here, we go back and let me run this script with the ampersand. You can see that we did a drink of 3, which we were expecting to return you've got yourself a drink. And we did a drink of 1, which we were expecting to return no drink for you. This happened just the way we thought it would. So we can build upon these conditional statements. Let's talk about a different scenario with multiple parameters. Let's say that you are an adult, and here in the United States, if you're an adult and you want to have a drink of alcohol, that requires you to be of age at 21. So in order to purchase alcohol, you have to be 1, of age, and 2, have money. Now, if you don't drink, that's perfectly okay. This is just an example scenario. So here, let's say we wanted to buy alcohol. We have to meet that age requirement of 21, and we have to meet the requirement of money. Now, we could be in a situation where we meet the age requirement, but we don't meet the money. Or we could meet the money requirement, but we don't meet the age requirement. Or we could be in a situation where we don't meet the age requirement and we don't meet the money requirement. So let's set this up to think through this and how these scenarios could play out. So let's define alcohol here. And we need 2 parameters. We're going to say age and money. So first statement here is going to be our leading if, and we're going to say if age is greater than or equal to 21, because we need that condition to be true, and our money is greater than or equal to 5. So we'll say a drink costs $5. We're going to return we're getting a drink. Okay, now, since we're going to have multiple conditions here, we're going to introduce something called else if. Else if here is written like this, ELIF. So else if our age is greater than or equal to 21 and our money is less than $5, then let's return come back with more money. We need another else here because we have another condition, right? So we're going to say, what if our age is less than 21 and our money is greater than or equal to 5? Well, we're going to return, nice try, kid, because we're not old enough to purchase this drink. And then lastly, in our else scenario, if we are not meeting any of the conditions above, which means we won't have the age, we won't have the money, then we're just going to return you're too, if I could type, sorry, you're too poor and too young. So let's go ahead and run this a couple different times. So let's go ahead and print out alcohol, and we're going to give our two parameters. So let's say 21 and 5. Let's print out again alcohol, and let's give a parameter of 21 and 4. And then let's print out one last time of alcohol, and we'll say that we are 20 and 4. So we should meet a few different conditions here, right? So at 21 and 5, we should return we're getting a drink. At 21 and 4, we should return come back with more money. And at 20 and 4, we should return you're too poor and too young. Now, if you want to add in a fourth condition here or a fourth print statement and you want to return the nice try, kid, you're more than welcome to do that as well. So go ahead, hit Control S or save your script out, and then let's go ahead and run it. And you can see we return exactly what we thought we were going to. We're getting a drink, come back with more money, and you're too poor and too young. So this is it for conditional statements. Hopefully this makes sense. Again, our conditions are based on certain items, right? So money here, for an example, if we have the money, we're getting a drink. If we don't have the money, we're not getting a drink. And then we can build upon that. We can have multiple parameters here. So if we're not old enough to buy a drink, or we don't have enough money to buy a drink, or we don't meet any of these scenarios, different things can happen. What you need to be thinking about as a developer, programmer, or even writing these scripts is all the scenarios that could happen in these situations. You got to think of the logic behind it. So when you're building out a script or you're building out your first program, you need to think logically. If I make an if statement or a conditional statement, what's the logic behind it? So a lot of times, for example, in this scenario, we might have thought, okay, well, if I don't have the age or the money, okay, but you got to think about what if I do have the age but not the money, or I do have the money but not the age. So you have to think through everything in your head and make sure that it's all clicking. And this just takes repetition and just sitting down. The best way is with sitting down with the pen and paper and not writing this in code form, but just writing this in a sense that makes sense to you, thinking through it logically, and then writing it out in code. So from here, we're going to go ahead and move on to list in the next video. So once you're all caught up here, let's go ahead and move right over there. Okay, now let's talk about lists. So lists are data structures. Now these data structures are changeable. We can reorder them, put them in a list, right? So they're just a group of elements. And when you have this list, everything inside that list is called an item. And the best way to think of a list is to think that it lives in between brackets. You're going to see other things later on that look like a list, but it's not really a list because of how it's defined. And how we're going to define lists is because they live in brackets. Just like a string might have quotes around it, a list is going to have these brackets around it. So let's make a new line, and let's go ahead and just do something along the lines of lists. And we could just say something like have brackets, like this. Okay. So let's go ahead and make a list, and then we can kind of go from there. So let's define a list of your favorite movies. Now you could put in whatever favorite movies you like in here, and I'm going to put in something like When Harry Met Sally, The Hangover, The Perks of Being a Wallflower. And this is getting kind of long, so I'm actually going to move this over a little bit for us. And we'll say one more. Let's pick 4 movies. We'll do The Exorcist. Okay. And now we have this list. Again, lists just live in brackets. So we've got list item 1, item 2, item 3, and item 4. Okay. So let's go ahead and print these. So if we were to print out something like movies, and we said we wanted to print the first item out of movies, let's go ahead and try to print When Harry Met Sally. So we'll print the first item. So put a bracket around it just like this. We'll print it out and we'll see what happens. So let's save it. And what's it going to return for us? It's returning The Hangover. So item 1 is not item 1 as you see it. So when we talk about items, when we talk about numerical order here in Python, item 1 is actually going to be referred to as 0. So make a note here for yourself that this will return the second item. So if we wanted to return just When Harry Met Sally, we would actually put in movies 0 like this, and we could say returns the first item in the list. Okay, and we can save that. And let's go ahead and give it a go just to do proof of concept, and there you go. So remember that everything starts with 0 and not 1. So when you're thinking about things, let's think about them with 0 as the beginning number. So let's go ahead and do a few more different prints. What's going to happen when we print out something like this? We'll say movies, and we'll do 1 through 3. Do you have a hunch? Let's go ahead and save it. Print it out here, and it will take the list here of starting at 1, and it'll end before 3. So let's say we want to pull a couple items out. The first number that we're going to pull out is going to be the one that we want to start with, and the last number that we're going to pull out is going to be the number where we're going to stop. So The Exorcist is 3, but if we wanted to actually pull down The Exorcist, we would have to pull down 4 here. So if we want to try to grab more than one thing out of the list, we can absolutely do that, but we have to know where to stop. So now we incorporate The Exorcist here. Let's say we wanted to grab everything in a list, and we wanted to grab everything after a certain point, right? We could say something like movies 1 like this, and then we should be able to grab every single thing. And that does pretty much the same thing here. So if we had 30 items here, it would grab all 30 items in this list. If we wanted to grab 3 items, as we did before, we would do 1, and then you would just add 3 to that, to 4, and it would stop. So a little bit confusing. This takes a little bit to wrap your mind around, but the good thing here is that you take notes. You can make notes however you feel comfortable with, and these tricks should be useful for you. So let's try another thing. What if we said something like movies, and we did this one in reverse? We just did something like this. And we did save. Let's print it out. What do you think is going to happen? It's going to print When Harry Met Sally, because it's going to stop at the 1. We never get to 1 here. Again, similar situation when we have this set to 3. We never get to 1, we stop at 1. So we're going to grab everything before 1, which is going to be just be When Harry Met Sally. We could set this to 2, and we would grab The Hangover in this as well. And just to prove concept here, so that I'm not crazy, you could see here The Hangover gets added in because we get 0 and we grab 1. You could also think of this, if you don't confuse yourself, as grabbing 2 items out of the list. But make sure you don't confuse yourself, because if this number were to be like 2 through 4, then it would be something completely different, right? So you need to make sure that you understand where from the list that you're actually grabbing. I'm just going to Control-Z these back. There you go. So from here, let's do 2 more tricks. Actually, we'll do one more trick, and then we'll move into some other items related to lists. So if we say movies like this, and we want to grab the very last item, we can just put in a -1. And so grab the absolute last item off the list. That way, like if you have a list that's 2,000 items long and you don't know where it ends, you could just do -1 and it's going to grab the last item for you. And then you can see there, it grabs down The Exorcist. So cool little tricks. You might not use these for a while and you probably won't see these come through, at least in anything we're going to really do in the course, but they're still incredibly useful to know about because they are included in the basics of Python. So if you're going to know the basics of Python and you will use these sometime in your lifetime, it's useful to know this kind of stuff. So we can also do some things with lists as well. We can print out the length of our list. So we could say length of movies, something like this, and give that a go. And you can see that there's 4 items in that list. So we've seen length before with strings and it took every single character inside that string. Here it's taking every single amount of item inside a list and it's printing that out. We could also append items to the list. So we could say something like movies.append, and what if we really like Jaws and we added that into our favorite movies? You can't have too many favorite movies, come on. So let's go ahead and try printing that out. And, well, we'd have to actually print it, sorry, movies.append, and then we'd say print movies now. And it should print out with Jaws added in. Where do we think Jaws is gonna actually add itself into? Well, if you said the end of the list, you were correct. So when we append something, we append it to the very end of the list. What if we wanted to delete something from the list? We could say something like this, movies.pop and print movies. Let's see what happens here. And now we got rid of Jaws. So when we append to the end of the list. If we want to delete the very last item in the list, we just use pop. Now, if we wanted to delete something like the first item or the second item, we could do movies.pop and let's say 0. We print movies. This will remove the very, very first item in the list we should see When Harry Met Sally disappear. And there you go. No longer is When Harry Met Sally in our list. So this is a quick way that we can remove these items and on the fly, if we need to get rid of this. So the high level overview here, and the thing that you really need to take away is that lists have brackets. We're going to see something called dictionaries later. We might see something called tuples later, and they all look very, very similar. But here, lists have brackets. Inside those brackets are what we have that are called items. Okay, and there are many different ways to return items. The reason that I'm showing you these different ways is so that you can get familiar with the syntax, that we start our list or our items with 0 and not 1, and that we can grab from these lists in different ways. Okay, and this will come back into play later with how we can utilize the same kind of syntax with other items as well, or other things in Python. So we can also utilize, printing out length, or we can do a .append and add to the list, or a .pop. And there's a lot of different things we can do here to append to these lists or remove from these lists, etc. So this is just the basics, but hopefully what you take away from this is that lists have brackets, and there are items in a list and they start with 0. Those are the key takeaways. So in the next video, we're going to briefly talk about tuples, and then we're going to move on into looping. So let's go ahead and do that. Okay, let's briefly talk about tuples. Now, tuples are like lists, but they're not like lists. So lists are what we call mutable, meaning that they can be changed. Now, tuples are immutable. They cannot be changed. Now, for this course, this is the last time you're going to be seeing tuples, but it's important to define what they are so that you know them, you know how to identify them, and they're just in the back of your mind as, hey, I know what a tuple is, and that thing is immutable. I can't change it once I have it. So let's take a look at a tuple. Okay, let's make a new line here and start a comment we could just say tuples do not change. And also we can put parentheses like this, because remember, lists had brackets. Tuples have parentheses. So we're going to say something like grades. Now we're going to have an item that won't change. So we're going to define grades here as just A, B, C, D, and F, which is common for the US grading system. And this is an example of a tuple. So again, we have parentheses instead of brackets. Now, if we were to go in here and we were to try to do a grades.pop, for example, and try to remove one of these, not going to be possible. Or a grades.append, we're not going to be able to put something else in here. This is immutable. We cannot change this once we have it defined. So we can go ahead and print out our grades. And we could say print out grades. Let's print out a B. And that will work. And you can see now we printed a B. So we have similar features or abilities that we did here, but we cannot change it in any way. So once we have this defined and set, that's it for us. So this is it. I just wanted to quickly show you what a tuple is. Again, we're not going to get into it at all in this course, but it should be defined, and we should know the difference between a list, which is mutable, versus a tuple, which is immutable. So in the next video, we're going to get into looping. So we've already covered looping in the bash scripting section of the course, but we're going to go ahead and get into the Python version of looping as well and make some more sense of it. So I will catch you over in the next video. Now moving on to looping. So we introduced looping in our bash scripting video. And we took the for loops and we made one-line for loops, and those should be familiar to you. So a for loop is just a start to finish of an iterate, right? We wanted to run that ping scanner, for example, and we started at the 1 and we ended at 256 on our IP sweep. Now we're going to introduce that in Python form, and we're also going to introduce a while loop. Now the while loop is going to come back into play later on in this course, especially when we get into the exploit development part of the course. So a while loop, just think of it that it executes as long as something is true. So let's make a new section here. We're going to do a new line as usual, and we're just going to go ahead and just say something like looping. And let's go ahead and start with for loops. So we'll do for loops, and let's note that this is just the start to finish of an iterate. Okay, so let's say, for example, that we have a list. Okay, let's go back to lists and we'll say vegetables, and let's just throw some vegetables in there. You can pick whatever you want. I'm going to do cucumber, I'm going to do spinach, and how about cabbage? Okay, and again, your list can look however you want it to look. Now for this for loop, we're going to say for x, and remember, same thing with bash, x can be whatever you want to call it. You can call this for veggies, you can call it whatever you want. I just like to use a letter because it's simple to type out. We're going to say for x in vegetables, we're just going to print x. And what do we think this is going to do? This is going to go through this list, right? It's going to say for every item in vegetables, I want you to print that out. So we're going to grab cucumber, we're going to grab spinach, we're going to grab cabbage. It's going to print, print, print. So let's take a look at that. Let's go ahead and save it. We'll run our script here. You can see that it printed cucumber, spinach, and cabbage. So again, you've seen this before, just a classic example of a for loop. As long as we have something to iterate through, we're iterating through a list here. And remember before, again, we were like, sequence 1 through 255. We iterated through that to do our ping sweep. So we're just iterating through something. That's it, really basic. Now, we also have while loops. So we'll say while loops, and these execute as long as true. So later on, you're going to see something that says while true. It'll be capital, while true. We're going to do something. Don't worry about that right now. For this example, what we're going to do is we're going to say I equals 1. Okay. And so we set a variable I that's equal to 1. Now let's do a while loop. We're going to say while I is less than 10, I want you to go ahead and print out I, and then we're going to iterate I plus equals 1. So this should all start tying together from what you saw earlier. Remember that we had the plus equals and we're adding 1 to something. So what we're doing here is we're saying, hey, I equals 1. And you know what? While I is less than 10, I want you to go ahead and print out I. Then we're going to say, hey, I is plus or equal to 1. So that means I is now going to be 2. Then we're going to go back through this loop again. Now, while 2 is less than 10, go ahead and print out that it's 2, make it 3. 3 is less than 10. Over and over and over and over until this condition is no longer true. The second that this I becomes 10, this loop is now no longer true and it's going to stop. So we're going to go ahead and save this here. Let's go ahead and print this out. And you can see that we just printed 1 through 9 as expected. So you're going to get to see these again. You're going to get examples of them again. As of right now, I just want you to understand that a for loop is an iterate and a while loop executes as long as true. Okay, so don't worry about how they're used quite yet. Just understand what they are, what they mean, and then you're going to see them come up in practical examples later on. It'll make a lot more sense as we go through it. So we're going to move on to the next video. I'm going to go ahead and catch you over there. Okay, we are moving into, I don't want to call it advanced Python. I just want to say more advanced than where we were before. If previously we were in a 101 class, we're moving kind of into some 102 material. I wouldn't even call it 201 material. This is just more advanced beginner stuff. How about that? So what we're going to do is we're going to go ahead and start a new script. That way we can kind of have our new 102 section here and kind of improve upon what we've been doing a little bit. So what I want you to do is I just want you to gedit, and we'll just call this new script.py, put a little ampersand at the end as usual. And we're just going to declare our bin python 3 here, if I can type it out, bin python 3. And we're going to go ahead and talk about our first concept, which is going to be importing. So importing is important. When we say importing, modules are existent in Python, right? And we have a lot of them built in, but there are these modules that are not built in, but available to us. For example, a module called sys. Now, sys does a lot of important things. Sys has to deal with anything related to system functions and parameters. One system function and parameter that we can do is something like printing out the version of Python that we're running. So we could say print sys.version. Okay, now if we go to do that and we say save and we just go ahead and say python 3 new script.py, you can see the name of sys is not defined. So we're getting an error here. Well, that's because we haven't imported it. So what we can do is we can say import sys, and up here we can go ahead and just give this a nice comment next to it, and we can just say that sys is a system, a function, and parameters. Okay, and then let's go ahead and save this, and now let's go and run it again. Now you can see that we are running Python 3.7.5 RC1, and we have now successfully printed this out. Why did this work? This worked because sys does not by default come imported. Some items are already built in by default. Sys is not one of them, but sys is very important and we're going to use it over and over again. So you're going to see it a lot. One of the most frequent, if not the most frequent, along with OS is another one, import OS. You're going to see a lot of that over and over. So why are we going to see this? Well, we have things like argv. So argv is arguments. So when you think about from the Bachelor lesson, like $1, you know, when we had an argument and we were doing our ping, like our script.sh, and we had our IP address here as $1, something along those lines. Well, those are the same thing. We just call it argv in Python. That's something. Another thing is if we want to say sys.exit, which you're going to see again later in this course, we do a sys.exit, that exits Python cleanly. We need a sys.exit. So you're going to see sys quite repeatedly. On top of this, there's more things that we can do with modules. Let's go ahead and delete this. And let's say that we wanted to import another module called datetime. Now this does exactly what you think it does. But what if we wanted to import a specific part of datetime? We didn't want to import the whole thing. We just want to import one module. We can say from datetime, import datetime. So we can do the same thing with sys. We can import a specific part of sys, or we can import all of sys. So with datetime, we're importing a specific part of it, right? And we can do something like print datetime.now, something like that, and it should print us the date time. So do this, you can see now today's date is 11/16/2019 and what time we're recording. So we can also do another nifty feature when it comes to importing. We can import with aliases. So instead of from datetime, import datetime, we can say import datetime as something like DT. You could say import with alias. And instead of having to write datetime.now over and over and over, something like that, we can just write DT. It's shorter, we know what it means, and we don't have to write out datetime, which is kind of lengthy. So print it again, you can see it still works. So importing is important. I'm going to say it again. You need to know that we're going to be importing certain modules out of Python. Most of these are built in. There are occasional times you're going to have to go out and download something and put it in your library and import it that way. But for this course that we're doing, you're only going to be importing from things that are pre-existing with Python. So not everything is automatically ready to go. Sometimes you have to import things in order to improve upon your script or make it do what you want to do. So we're going to build off of this when we start writing our scripts, and you're going to see this repeatedly. You're going to also see this again when we do our exploit development part of the course. So let's go ahead and move on. We're going to move on to some advanced strings, and we're going to get close to wrapping up here and start building out some cool little Python scripts. So I'll see you over in the next video. Okay, let's talk about advanced strings. So everything I'm going to show you is not going to be used in this course, but I still think it's important to know. And there's some important syntax in here to know as well, and just different ways to handle the information that is in front of you. So let's go ahead and just print out a string, or let's make a string first. Let's do a string of my name. And we'll just say, my name is Heath. And similar to before, if we printed out our name, we could say print my name. And then if I wanted to print the first initial of my name or first letter in my name, I would just do something like this, right? So this should be familiar. And if we wanted to print out the last letter, we could just say -1. This should be familiar to you from the list lesson. So if we go ahead and we print this, we just say Python 3, and we do our new script again. You can see that we have big H and a little h because my name ends in both, starts and ends in both. So we could also do something like take a sentence, and we could say sentence, this is a sentence. And if we wanted to print out the first word of the sentence, we would have to know the amount of letters in it. So we know here that there is 1, 2, 3, 4. So this would be 0 through 3. So let's say if we wanted to print out sentence here, and we knew 0 through 3. So remember, we don't have to put 0. We could just put something like this. And then if we did through 3, it would only cut off at the I. Remember, we have to go one further from our list lesson. and we'll be able to print out the word this. We could do the same with sentence. We could go forward a bunch if we want to, or we could do a -9, because this is 9 characters long, through something like a -9 through -1 would pull out that whole sentence, or the word sentence, I should say. So we can manipulate data this way. We can also split data. So we could say something like print and do sentence.split, and this will split based on a delimiter. Now, the delimiter here is by default a space, and we covered delimiters in bash scripting, and we're just going to say, hey, every time there's a space, I want you to split out this sentence. Let's take a look at what that looks like. I made a mistake in my script. I didn't spell sentence correctly, which caused an error in the initial script. So let's try that again. So you see here it says this, that's what we were expecting from this one. And here we have this as a sentence. It now breaks these out into individual words based on a delimiter. So let's go a little bit further. We can join a sentence as well. So let's have a scenario here. Let's say we want to split a sentence out. We'll say sentence split is equal to sentence dot split. And now we just split out the sentence, right? And we're putting in this variable of sentence underscore split. Now we could also join a sentence. So let's make a new variable and we'll call it sentence join. And here we can just say, based on a delimiter, I want you to put a space in between everything here. So every time you see a word in this sentence split, so let's go ahead and join. Anytime you see sentence split here and there's a new word in it, I want you to go ahead and join those with a space. And then we can go ahead and print out sentence join, and let's see what happens here. This is a sentence. So it brought it all back for us. So not only can we take away and delimit a sentence by splitting, we can also join a sentence and add our own delimiter in there as well. So one of the most important things that we need to talk about is what happens if we have a quote and we say something like, he said, give me all your money. Well, we need to add quotations in here, but if we do quotations like this, well, that's just making things really weird, right? Look at the color of the script. You can already tell it's going weird. That's going to throw an error. But we can use single quotes and double quotes, and it'll work. We could also use single quotes here, double quotes inside, double quotes on the outside, single quotes on the inside, and that's a way to have quotes inside of a string. So let's go ahead and print that out. But let's say that you were insistent and you wanted to have double quotes and then double quotes here. Well, we could do a little bit of character escaping. So we could utilize this backslash here and say, hey, we're going to keep this string a string, and then I'm going to end it right here. So this will tell me that from here to here, ignore these characters, right? So we're going to treat it as a string. Don't treat it as a quotation and end of string. So let's run it again, and you can see that quote, once we print it, we could say print quote, and we'll actually run it here. He said, give me all your money. And I realized that I tried to print earlier and probably did not print this quote because I never had the print in there, so I'm sorry for that. But we could do it either way. Again, we can put the single quotation in here, and you'll see the single quote works, but if we were to put in a double quotation, it would break it. So I'm going to Control Z a couple times, and this is what the syntax should look like. This is very, very important. If there's one thing you're going to take away from advanced strings, please take this away from it, because you need to know how to do some character escaping, and that you will encounter that again in your career. So a couple more things. Let's say that we want to have a string here. Let's just say we'll call the string too much space. And we have something like hello. And we just, copy data, put it into this, and somehow too much space in here, we can strip out the space. So we can just print too much space here, and we can do the same thing as we did before and do something like strip, like this. Save it, and look what happens. Now it's just going to print hello. There's no space around it. We're good to go. So that's a nice little feature. Another feature that we should know is, let's say we had something like print a in apple. What's this going to return? True. What it's looking for is, does A exist in apple? Well, what if we did a lowercase here? Try it again, and you're going to see that it's false. So it's very case sensitive. Well, what about we wanted to say, hey, is there an A in the word apple? And we don't know if it's capitalized, not capitalized. Well, we might say something instead like, hey, we're looking for a letter of A, and we're looking for the word of apple, right? But what about we say print letter.lower, and then we say in word.lower, like this. Now this becomes improved because we're looking for a specific letter inside of a specific word, and when we lowercase everything, we lowercase this letter, lowercase all these letters, then we're looking for a specific letter in a word. We don't have to worry about case sensitivity, and you will see this logic come into play when you're thinking about looking for specific items or specific key phrases or matching anything specific. You might want to consider putting everything in a lowercase and then trying to find it that way, unless you are critical on case sensitivity. So this will probably come up again in your career as you look at code. So if we run that again, now you can see that it returns back true. So one more thing I'm going to show you, and there's a lot of things that we can do with advanced strings. I don't want to beat too much into it because I really feel that this can get into overkill because there's so many things and tips and tricks that I can show you, but I really feel like some of this can be out of scope for the course. But I do think that as long as you're taking good notes and it's valuable now, you're going to have that as something to remember and look back upon as you do more Python development. So one more thing is a format. So let's say that your favorite movie is The Hangover. And we'll just keep that as a string. And let's just say something like print my favorite movie. Now, we have done in the past is, and we could just say something like this, plus, string, if it's not a string, or we just say movie, right? And then we'd have to add a period in here, something along those lines. We can improve upon this. We could say my favorite movie is, and then we can just add a little placeholder here and then put a period. Now, what we do after this is we just say dot format, and then we say movie. And now it knows to put in the movie that we have here, or the variable that we have stored in movie. It knows to put it into these brackets here. We save this and watch what happens. My favorite movie is The Hangover. So you don't have to do a bunch of spacing, and if things get weird, with your string or how to write out your sentence, it's very easy to just have these placeholders, and then if things change, it just updates easily. So this is a very nice way to hold things in a placeholder without making these weird formatting changes. So I like this method opposed to the concatenation method that I showed you in our first video on strings. So if you're going to take away some things today, just take away that, we have different ways of doing things. We've shown you with the list before of the 0 and the -1. I told you it was going to come up again. Just know that, again, 0 is the first item or first letter or first whatever when we're talking about Python and we're talking about our variables, lists, strings. Always start with a 0. There's different ways to do the same thing and apply them across other items, right? So I've shown you this with lists, I've shown you this with strings. So get those wheels spinning and think about how you can utilize some things. Now, sentence has all different kinds of methods that we can use with it. And again, we're just touching back on methods and making it a little bit more advanced. But you see that we can split a sentence, we can join a sentence, we can strip a sentence, or we can strip a string. So understanding that there are a lot of cool methods. The lower method, we could do an upper method. We've talked about those as well. Knowing the different types of methods per, say, like a string, or per class, or however you want to combine it together, is important as well. So always do your research when you are looking into, how can I improve it? So if you're saying like, hey, is there a way to make something uppercase? Just go to Google and say, hey, how do I make a string all uppercase? And of course it's .upper, but if you didn't know that, then the Google machine would know that for you. And a lot of your code is going to be found on Stack Exchange or on Google, etc. So just be aware that these things exist, and be aware that there are better ways to format your strings, and there are important syntax when it comes to escaping your quotations as well. So that's it for this lesson. We're going to have a couple more little lessons here, and then we're going to move into script building, and then we'll be starting our hacking journey. So I'll catch you over in the next video. All right, we are in the home stretch, everybody. So we're going to cover dictionaries now. And when we think of dictionaries, we need to think of key value pairs. So let's go ahead and make a new section called dictionaries, and we'll just note key value pairs. Probably put a slash here, key/value pairs, and we'll also put a little note of curly braces like this. So let's talk dictionaries. So let's say we have a dictionary and we want to have a menu. Let's make a drink menu. Again, make this however you want. I'm going to make this based on some alcoholic beverages. You can absolutely make this more, PG or PG-13 or however you want to make it. But let's say a White Russian. We go to a bar, there's a White Russian on the menu, and that White Russian costs $7. And there's also an Old Fashioned, and we just say that's $10. And then we have a Lemon Drop, which is $8. So we've got these, and we'll close off this with a curly bracket. And this is what a dictionary looks like. So if you were to print out drinks, we would return our dictionary. So let's do that. If I would make this the correct syntax, this would work very well for me. I am human after all. So you see here, White Russian 7, Old Fashioned 10, Lemon Drop 8. So what you can note here is that the drink is your key and your price is your value. So you have your key value pair here. So key value, key value, key value. Let's think of it as another way. We don't have to just have one parameter or one value. We have to have a key. We can have multiple values to a key. So let's talk about employees. And I'm going to use one of my favorite TV shows, which is Bob's Burgers, to do this. So let's say we have employees and we have different departments. So let's say we have a finance department. Okay. And inside the finance department, we've got Bob, we've got Linda, and we've got Tina. So we got 3 employees in the finance department. Then we've got an IT department. And inside of IT, there might be Jean and Louise. We'll add Teddy to this too, why not? I'm gonna have to move this over because it's a little bit long. And then let's do one more department. Let's say that there's a department of HR, our favorite department. And we'll say there's Jimmy Jr. and Mort. All right, so this is our dictionary. Now again, we can print out employees and we should be able to see our dictionary here. Save this, give it a print. Okay, you can see finance has Bob, Linda, Tina. IT has Jean, Louise, and TD. and Jimmy Jr. and Mort are in HR. I'm going to fix this typo. And all right, so let's say that we want to add a new key value pair. Well, we can say, let's say there's a new department. And we could say there's a new department called legal. So employees, and let's add in legal. And then we'll say, in legal, there is Mr. Frond. All right. And this will add a new key value pair, something like this. All right. So we'll save this, go ahead and just print it. And if I were to write print afterwards, print employees, and we'll save it. Let's print it one more time. Now you see that legal has been added with Mr. Frond working in legal. Okay, let's do another. Let's say that we've added somebody to the sales team, and let's do it this way. We didn't have a sales team before, but we do now. So we can also do an update, something like this. We could say update, and then we can add in sales. And we can say, hey, we've got a nice new sales team of Andy and Ollie. And it'll look something like this. So now when we print out employees, we should have Andy and Ollie on the sales team as well. So there's multiple ways to add in new key value pairs. So we can copy this and paste it over here as a key value as well. So we can also update things. This is the last thing I'm going to show you. We can also update things. So we could say, let's go back to our drinks. And let's say that we've got the White Russian. And let's say the White Russian is no longer $7. Our menu has changed and it's now $8. So we're going to make $8, and we'll just print out drinks. And we can save that, print it, and now you can see the White Russian is now $8 instead of $7 from before. We can also get some items out of a dictionary. So we say print drinks.get, and we'll just get the White Russian. And let's see what that returns. So you can pull specifically from a dictionary here. And you see that the White Russian has a value of 8. So this is it for dictionaries. You're not going to really see it come up in this course, but again, this is another valuable thing with Python to know. So we have covered lists, which have brackets like this. We've covered tuples, which have parentheses, and then now we have covered dictionaries, which have the curly braces. And now when you're reading code, you should be able to identify all of them differently. This is why this was important. Everything has been building upon up until this point, right? So now you should be able to identify, okay, I see those curly braces. You know, that's going to be a dictionary. Or I see these brackets here, that's going to be a list. So keep that in mind, and moving forward, you should be able to now start reading this code and understanding this code. And from the beginning, I told you we don't have to be developers, but we do have to be able to read code. So the more I show you, the better off that you're going to be. So we're going to wrap up this lesson. We've got a couple more before we start building our scripts, and we'll be good to go and move into hacking. So I will catch you over in the next lesson. Welcome to your final module before we start working on scripts. So this last module is a very important one because we have to define what sockets are. So we're going to be using sockets to connect two nodes together. Really, that's it. In more layman's terms, what we're doing is we're going to use sockets to connect to an open port and IP address. So you're going to see this when we build a port scanner. You're also going to see this later on in the exploit development portion of the course, where we have to reach out to a specific port and IP address, establish a connection, and send malicious data. So what we're going to do here is we're going to just build out a simple socket script, and we're going to connect to an open port with that script. and it'll start to make sense. And then when you see it in the next video, when we build out the port scanner, make a little bit more sense. And then you see it again in the course, you're going to say, hey, I remember that we use sockets for connecting to ports. So here's what we're going to do. We're going to make a file and call the file s.py. You can call it whatever you want, just do not call it socket.py. If you call it socket.py, you're going to run into issues because it's going to think it is a socket. So we need to define a couple of things first. So what we're going to do is we're going to, of course, shebang up top, do our bin python 3, and we're going to import socket. So remember, importing is important. We have to import socket up here at the top. Now let's define a couple of variables. So the first variable we're going to say is host, and we're just going to give that our local address here of 127.0.0.1. This is our local host. And we're going to define port, and I'm just going to give mine all 7s. You can give it whatever you'd like here. And I'm going to define another variable like this. S equals socket.socket, socket.af inet, socket.sock_stream. Now this looks long and intimidating. Please do not be intimidated by this. We are just making our life easier on ourselves. So we're defining a variable that stores all of this into one. And this is very, very common when it comes to sockets. This syntax here is very common. So what we're saying is, hey, we want S to equal socket.socket, and this socket AF inet, socket sockstream. So AF inet, just think about that as IPv4. We're connecting over an IPv4 connection. Socket.sockstream, you could just think of this as a port. So AF inet, IPv4, sockstream, it's a port. So let's say we want to make a connection. We're going to say s.connect. Now connect is just another part of the socket module. So we're going to make a connection here. And so if you think about this, we're using all this and then .connect, right? So we're declaring this, and then we have these two parameters here, socket AF inet, socket sockstream. So the AF inet, we need to say, hey, let's make this our host variable, and then this one our port variable. And we could, in theory, just put in 7777 and 127.0.0.1, but it's just easier to define those in a variable up top and then use them later to connect. So I'm going to go ahead and save this, and then I'm going to open up a new terminal in a new window here. And I'm going to utilize a tool that we have not used before. And this tool is called Netcat, and we'll use this later on in the course quite a bit. So we'll say Netcat, and I'm just going to say NVLP. This means I'm going to establish a listening port. I'm going to listen on port 7777 for a connection. So you see here, it says, hey, we're listening on any interface for all 7s. You don't have to worry too much about this right now. We're going to go into detail on Netcat at a later time. But all we're doing right now is we're waiting for anybody to connect to us. Now here we're sitting at our local host of 127.0.0.1. So we need to establish that connection, which is what we're going to do with this script. Now the script does nothing. It establishes a connection and that is it. So let's go ahead and take a quick look. We're just going to say python 3 s.py. Do that. Come over here and you see that we had an established connection made and then the connection closed. We didn't tell it to do anything. There's nothing here to say, hey, keep this connection open, send over some data, do anything at all. We just said, hey, make a connection really quick. And it did. It made a connection from 127.0.0.1 to 127.0.0.1. We connected to ourselves. But with this script, we have successfully achieved what we wanted to, which was to utilize sockets to connect one node to another node. That's it. So we're going to build upon this whole thing here. In the next lesson, we're going to build a port scanner. It's going to be a bad port scanner, but it's still going to be a great lesson. So let's go ahead and just take a look at that port scanner, and I'll catch you in the next video. All right, welcome to the last video in our Python module. So now we're going to be making a port scanner. And you heard me say in the last video that it's going to be a terrible port scanner. And it is, but it's going to be a functional port scanner as well. and we'll talk about what we can do to improve it and how we can think this through. So what we're going to do is we're going to go ahead and open up a gedit here. So I'm going to say gedit, and we'll just go ahead and call this scanner.py, and we'll do the ampersand at the end. And let's go ahead and declare that this is going to be Python 3. And now let's talk through some things. So there's going to be a lot of familiarity. Everything I've done up until this point has been for a reason, and you're going to start to see it all tie together. So the end goal of this project is going to be that we run something along the lines of Python 3 scanner.py, and we provide an IP address here. Now with that IP address, it's going to go ahead and scan through a selected port range for us and try to return back results, whether or not the port is open. So we're just checking if a port is open on a machine. So to do that, we're going to need a few things. So first of all, we're going to need to import sys. We're going to import socket, as we are going to make a node-to-node connection. And we're going to import datetime from datetime, as we're going to make a pretty little banner as well. So why was sys important? I told you sys would come back into play. So we have here an argument. So there are actually two arguments in theory. Argument 0 is that we're running scanner.py. Argument 1 is that we are running against an IP address. Now, since we're building this script out, we want it to take 2 arguments and only 2 arguments. So we're going to build that into our script from the get-go. So let's go ahead and just define our target. And it's always good when you're building out a script to have good notes in there as well. So not only that you can go back and read it, but if you send this to somebody else, they could also read through it as well. So put good comments in here, good notes, saying what you're doing. So in this instance, we're going to put an if statement, again, conditional argument here. And we're going to say if the length of sys.argv, remember this is the same thing as like a $1 in bash. We're going to take that and we're going to say if it's equal to 2, we're going to go ahead and do something. And what we're going to do is we're going to declare a variable of target. And we're going to say socket get host by name, and then we're going to get sysargv1. So we're taking the first argument. Again, this is the same thing as $1 like this in bash. Why are we doing this? Well, we're just translating a host name here to IPv4. Now this is not inherently necessary. We could just declare the target by input. It could just be target equals sys.argv1. But we're just taking an extra step here in case instead of somebody putting in an IP address, they could just put in like a host name. Say we have a host here and it's, like one of mine is called the Punisher. What if they put in Punisher? Well, if that Punisher name does DNS and it resolves to an IP address, it's going to go ahead and do that with this argument here. So we're just putting in an extra step, thinking ahead. We also need an else to this. So if it doesn't equal 2, if it's 3, if it's 1, if it's none, then we're going to go ahead and just print out and say invalid amount of arguments. And then we can actually take this here and we can put this into a print statement as well. We'll just print, just say something like syntax, Python 3, scanner IP address. Something along those lines. Okay, so I always like to save it and then just run it and make sure everything works fine. So let's go ahead and give it Python 3. We'll say scanner.py and we'll give it no argument. And it's going to say, okay, invalid amount of arguments, syntax is Python 3 scanner.py IP. So we'll just give it an argument here. Okay, so it runs. We met the conditions and we set the target variable to, well, to this, right? So that's okay for now. So let's go ahead, and I like to always put in a pretty little banner or something, you know, so let's add a pretty banner. And I'm just gonna do something like this. I'm gonna say print, and we're gonna do dashes. We'll just do 50 dashes. And then we'll go ahead, I'm gonna copy this just so it'll be easier. And let's go ahead and print a couple things. We'll say print, we'll say scanning target, and then we'll add a space, and we'll just do plus target. And then we'll say print time started, and then we can just do a space there, plus the string of date time dot now. Now that came back into play as well. So make sure you have 3 closing parentheses. So we've now utilized sys, socket, and date time, all of which we have seen in the past. And then that last copy paste here for the banner. So let's go ahead and save this and give it another go. And you can see it says, okay, scanning target, and it's resolving to this 23. This is not accurate, but you know, just let it do its thing. And then it's got the time started of the scan here. So you can see here, I'm putting in a host name, and it's trying to resolve to DNS to this. Maybe this is what it resolves to. I don't know, but we'll move on. So the next thing we're going to do is what is called a try statement. So we're going to try to do something, and if we can't do it, we have exceptions. So you'll see what this looks like when it's all built out. So go ahead and type try, and you're going to see try later as well when we get into the exploit development. So we're going to do a for statement. So for port in range. Now we need to specify the range. If we were going to do a full on port scanner, we would do for port 1 through 65, 535. Okay. That will take forever. We'll talk about why. I told you this was a bad port scanner. We'll talk about why we're not going to do this in a little bit. So let's go ahead and delete these, and we're just going to put something like 50 to 85. And I'll clarify why we're doing that in just a second. So on top of this, let's add in some familiar language. We're going to say s equals socket.socket, and then socket.af underscore inet, comma, socket.sock stream. Remember, AF inet is IPv4, sock stream is our port. So we're going to say socket.set default timeout to 1. Why are we doing this? This is going to attempt to connect to a port. If that port is not connectable, it's going to wait 1 second, and then it's going to move on. That way we're not sitting there forever trying to make a connection to a port. We set the timeout ourselves. So we're also going to store a result. So the result is going to be s.connect underscore ex, and it's going to be target, comma, port. So why are we doing this? Well, when we do this connect underscore ex, right, it returns an error indicator. So I'm going to put returns an error indicator. If a port is open, the result back is going to be 0. If a port is not open, it's going to throw an error, which is going to trigger a 1. So let's think that through. If result is equal to 0, then we're going to go ahead and just print out that this port is open. We'll throw this in here this time for a placeholder instead. We'll say is open, and we'll do format port. And then one more thing, I'll close it out, and we'll walk through this one more time so that it all makes sense. Okay, so then we're closing the connection. Okay, so we've got this try statement. Let's walk through it one more time. We've got a for loop here. Remember, for is just an iterate. We're going through an iterate. We're going through 450 so we're defining a port, right, in this range. So 50, 51, 52, all the way up to 85. We're going to repeat this whole process. We're going to establish our variable of s, which we did in the socket video, the previous video, right? We're just declaring, hey, I know I'm going to want to connect to IPv4 and a port. When I do make that connection, I want that default timeout to be 1 second. Okay, so then I'm going to store inside of a variable of a result, I'm going to say, let's connect to the target, which we've already established as sysargv1, and the port, which is our iterate here in our loop. And if that port is open, it's going to return 0. If it's not open, it's going to return 1. So if that result is 0, go ahead and print out that that port is open, close the connection, and then we're going to go back and try to establish another connection with port number 51, 52, 53. We'll loop through all this until we make it all the way through 85. Okay, so it's just one big loop that we're doing. Now, we need to throw in a few exceptions to make this code really work. So here's an exception. Exception, keyboard interrupt. So if you've been using Linux for a little bit now, you should know something like Control-C is a keyboard interrupt. So if we want to interrupt the scan, we need to define that there is an interruption here. So I'm just going to put in something like exiting program. Okay. And we're going to say when that happens, when there is a keyboard interrupt, we're going to say sysexit. That allows for that clean exit. Okay, there's another exception that could be occurred here, right? So we're going to say socket.gai error. And we're going to say print hostname could not be resolved. So if we can't resolve the hostname, DNS is failing us, we're just going to go ahead and exit out. And then one more. What if we can't make the connection to the address in general? Well, that's what's called a socket error. So we're going to say socket.error, and we're going to print out couldn't, if I could type, I couldn't connect to server. And then we're also going to exit this. So we'll say sys.exit. So I'll give you a little bit of time to catch up on this script if you're behind. I was typing fast and talking as well. So one more walkthrough. We're going to do our for loop through these specific ports, and then we're going to go ahead and have some exceptions. So we're going to try these with exceptions here. If we hit Control-C, we want to exit the program. If there's no hostname resolution, we want to exit the program. If we can't connect to the IP address that we specify, we want to exit the program. So we need to build in these exits. And these are this is that thinking logically that I talked about earlier in earlier videos, right? That it wouldn't hurt to build this out and then just think logically. And I will be the first person to tell you that when I build a script out and I write it, it's always terrible. First time's always terrible. 10th time, still probably pretty terrible. You have to start thinking of things logically. Like, you might not define an if statement at the beginning, right? You might have to think through that because you might need one argument or two arguments or three arguments and you don't know. So maybe this doesn't look like this and it doesn't look like the pretty banner in here either. And you just start with this for loop. And then you realize, well, maybe I should make that a try statement because what if the user wants to exit or there's no connection for a host name or there's no connection to the server? How do we get out of that? Or else we're just going to be stuck in this for loop until it's done. But if we get into one of these error situations, it's going to get weird, right? So, and then you start thinking through, okay, well, I know my arguments, so let me go add in a statement at the top so the user knows how to use it. And then maybe I'll put a pretty banner in there when it's all said and done. And it starts to really, design itself. Now, before we run this, let's talk about why this isn't great. This is going to sit here and run through one port at a time for a second of a timeout and then reiterate. This is going to take a little bit to run through these little ports. Now, when we get into scanning, you're going to see that there are tools out there designed that do it much better, much more efficiently, and much faster. This is not the best way. There is something that we could do called threading. Now, threading would take the process and run multiple processes at once for us and allow us to scan a lot of ports at once. That would be a potential idea here. And there's just improvements that we can do. Some of the things that we thought about already, like the socket get host by host name, you might not have thought about that in your first iteration. You might just say, hey, I want to just put it to IPv4. And what happens if, we supply an argument and the argument is something like a mixed bunch of numbers? It could be like 152, and then you got letters and somebody mistypes, or what if you give, an IP address that doesn't exist, something like this, or, maybe like 256 dot or 257 or something, you know, that isn't possible. How is that built in? How are we going to prevent that in our script? Right now, not that big of a deal. We're writing this for ourselves, so, you know, it doesn't have to be perfect, but if we write this for somebody else, we go put this on GitHub, we kind of want all those errors to be handled. And that's where these exceptions come into play, and these if statements at the beginning come into play as well, so we can handle those errors and those exceptions, and we can really start thinking logically on how an end user might fat finger something or break a program or do something even maliciously, possibly. So there are ways around this, and we'll talk about it as well when we get into a bash script that I wrote later on in the course, and we can kind of look at how that was written and how it strips out some arguments and prevents some human error. But we'll get to that later. So let's go ahead and actually save this now. We've got our scanner script, and we're going to go ahead and run it. So I'm going to run this, and I'm going to run this against my router. So my suggestion to you is to do the same, or do it to a machine that you know is in your network and has a port open. Why am I choosing my router in this specific range? Now, my router should have port 53 open because of DNS, and it should have port 80 open because I need to access the web interface on it. So I'm going to go ahead and run this, and I have a typo. So I have something called soccer here. I sure do. If you caught that originally, good job. You knew I was going to mess up. Let's try it one more time. And there you go. So it just ran through it really fast, said port 53 is open, port 80 is open, and immediately, you know, it knew. So it did its job. It went out there and it found port 53 and port 80, which is what I was expecting. Hopefully yours did the same. Now I could back this off to 1 through, you know, 65,535. And another thing we can do, if you want to see the speed, let's say 65,535, I am going to keyboard interrupt this, but we can print out something along the lines of checking port, and then we'll do something like this. Okay, and then we say dot format and then port. So when we save this and we run it, let's take a look now. So it's checking through all these ports. It's going kind of fast, but look, it's finding ports, but this isn't pretty, right? We wouldn't want this. We only want it to say when the port's open, but it's taking some time. We're on port 20,000 of 65,000. So on top of, you know, just being a little bit annoying, it's really, you know, throwing our screen into 20,000 lines now. So the only reason I would put a statement in here like this is if I was doing a couple numbers and I wanted to see, like, if we go back to 50 and to 80, we'll do 81. If we do this, it's a good way to see how fast your scanner's running. If it's running, it's a good way to have print statements in there if you might see any errors. And you could see it ran through 80 pretty fast and found 53 and 80 open. So I would delete this. If you want to do a full port scan, again, you could do 1 through 65,535. Go ahead and save that. Sorry if you heard my dog barking. It's really windy tonight. So we're going to go ahead and do it one more time. And now it should be a little prettier. And then as the ports are open, it'll print out. And if you want to get fancier, you could have a little thing at the bottom that says, hey, this took this long to scan. Here's how many ports are open, etc. So this is finding all the ports. So I'm going to go ahead and Control C, and you can see now exiting program, our keyboard interrupt worked. So everything is working really, really well. And that is it. So that's it for the Python series. And hopefully this all made sense. This all built upon it. You know, we could take this, and the goal here again is not to be an expert in Python. The goal here is to get you interested in Python, to get you seeing that it's really not that bad. And in about an hour and a half to 2 hours time, we started with nothing and built out a nice script that all, you know, just built lesson upon lesson until we got here. So we're going to move on and actually get into the hacking. You have successfully completed all of your foundational courses. We've got the Linux down, we've got the networking down, we've got the Python down, and now we're ready to get into the good stuff. So I'm very excited to do the hacking. This is our strong suit. This is our bread and butter, and we're really going to knock it out of the park. So I will catch you over in the next video when we start learning about hacking. Okay, before we get hands-on, I have to give you a little bit of death by a PowerPoint, but it's for good reason. So we need to introduce the 5 stages of ethical hacking. These are the 5 stages that you will go through on every assessment. So before we do that, let's first make a big note. From here on, we are moving into the ethical hacking portion of our course. We're going to learn malicious things. Please only use the information learned in this course for ethical purposes. Do not attack your neighbors. Do not attack anybody that you do not have explicit permission to do so. You can and will get into trouble for doing that. So with that out of the way, let's talk briefly about the 5 stages of ethical hacking. So we start up at the top, and we actually start with what is called reconnaissance. This stage is also known as information gathering, and there are 2 different types. There's active and passive. Now, passive is saying, like, going out to Google and searching for somebody. Say you're given a client and you want to look at their Google, you want to look at LinkedIn, you might be looking for, I don't know, a picture of their badge or an employee's name, or maybe an employee's Twitter page. That's all passive. You're not actually going out to the company's website and doing anything active against it. Now, active reconnaissance kind of falls into place with the second phase, which is scanning and enumeration. Now that is active. That is where we go out and we take tools such as Nmap and Nessus and Nikto, and if you've never heard of any of those, that's fine. But we take those and we scan actively against a client. Now what we're looking for are open ports, vulnerabilities, different items. And with what returns on these results when we do this scanning, we also perform what is called enumeration. Enumeration is just looking at items and digging into them to see if we can find anything of value. Say that there is a web server running on port 80. We see port 80 is open and it's running something like Apache 1.2, which would be really, really outdated. We would go out to Google and we would say, Google, do you know if Apache 1.2 has any exploits for it? And we would do research. That's the enumeration portion of it. So once we do our information gathering, we do our scanning and enumeration, then we move into the gaining access portion. This is also known as exploitation. We will run an exploit against the client or against the vulnerable service or whatever it may be to try to gain access into a machine or into a network, into an environment, etc. Once we have that access, the process starts to repeat. We do scanning and enumeration again, and we also want to maintain that access, right? So if we were to get kicked out, okay, or a user shuts down their computer, how do we maintain that access so when they turn their computer back on, we still have access to it? And then lastly, there is the covering tracks. You want to delete any logs that you may leave behind. You want to delete any kind of malware that you upload, which is more important as a pen tester. Any accounts that you create for any reason, you want to delete those as well. You really just want to clean up, is a good way of putting it. Covering tracks is the more hacker way of putting it, but as a penetration tester, you really just want to clean up. So we're going to go heavily through steps 1 through 3 in this course. We'll also cover 4 and 5 briefly, but the process and methodology never changes. Regardless if you're doing network, if you're doing web app, or if you're doing a different type of assessment, it's all similar in this 5 stages of hacking. The tools might change, the attack methods might change, but the overall methodology is always the same. So that's how we're also going to structure this course. We're going to go in first and we're going to talk about information gathering and reconnaissance. Then we're going to move into scanning and enumeration, and then we'll start with exploitation and do that repeatedly till we get it inside of our heads and it feels almost second nature, right? Once we have all that done, we'll do some practice boxes, give it a go, see how we do. We'll move into the internal side of things with Active Directory. We'll start working with our web applications and our wireless, and we will touch on the maintaining access and covering tracks, but you're going to see this methodology over and over, and you might also get this question on an interview, to describe the 5 stages. So it's important to know these. It's just something that every ethical hacker can rattle off pretty quickly. So have this written down, think about it, keep your wheels spinning, and let's go ahead and move on to our first section, which is going to be information gathering / reconnaissance. Let's learn some cool tools, some Google Foo, and just what kind of information we can actually gather on a potential client. So in this section, we are going to be talking about information gathering. And all the information gathering we're going to do in this section is going to be passive. So I'm calling this passive recon or passive reconnaissance. I wanted to give a brief overview of what we're going to be covering and talk about some high-level topics before we get into the weeds and really dive into our target. So let's talk about the different types of passive recon. So on the physical or social sides, physical meaning actually going on site and maybe doing a physical engagement, or the social engineering aspect of maybe doing a phishing assessment or even including it in a physical engagement or a phishing assessment. Just gathering this information from the physical social aspect is incredibly useful. So we have location information. So we might utilize something like satellite images, or often we'll go on site and do drone reconnaissance where we fly a drone around and try to gain information. And what we're really after with these images of this drone recon is we're trying to find out, hey, what does the building layout look like? Are there badge readers? Are there break areas? Does security exist? Do they have somebody posted out up front? Can you just walk right in the door? What does their fencing look like? Are there areas where they're just leaving the doors propped open? Where do people go out and smoke in these break areas? Because those are a good place to just walk up to somebody, light up a cigarette, even if you don't smoke, and just start a conversation, and then tailgate right in with them into the building. Now, the other aspect of this is the job information. So we might be looking for employees online. I might want to know somebody's name, job title, phone number, who their manager is. I try to get a good idea of what people look like. So if I see them on site, I have a good idea who they are. I also look for pictures. So I cannot tell you how many times a badge photo is posted on LinkedIn or somebody posted on Twitter. You can see all the memes out there about people posting their photos at work, and it's bad. It happens all the time. I see it to this day. So we're looking for badge photos. I'm looking for desk photos, computer photos. I had a situation once where somebody took a picture of her watching a game at work. She was watching a basketball game at work, and the basketball game was on her computer, and on her screen there, it showed all the different tools that they utilized at work. She had a work application open in this photo. There was a desk in the background. You can see different things, and it just gives us information. And that's really what we're after. What kind of information can we gather? Now, this course is not a course on physical or social, so I kind of wanted to give a high level of what to expect. We won't really be doing a whole lot of this in this course with this type of information gathering, but these are the things that you should be looking for. So if you are tasked with a physical assessment, do go out there and look for satellite images, try to get a good feel of the building layout, and also try to get a feel for who the employees are, who maybe the IT manager is, in case you're going to say, you know, I work for IT. They might ask you who your manager is. You might need to know those names. And of course, look for pictures. If you can find a good badge photo and what that looks like, you can make a fake badge, go on site, and you'll be way more passable with that badge. But sometimes they don't even look. It could be drawn in crayon. So from there, let's go ahead and talk about what we will be doing a lot of, which is the web and host. So when you get a web or a host assessment, the first thing you really should do is what is called target validation. So we're going to be targeting something on bug crowds. We're not really going to focus on this, but what we're going to do in the real world is we would validate the target. Now, there are situations where a client will give you an IP address or a website, and they might fudge it, right? They might accidentally fat finger it, put the wrong number, put the wrong letter in the website. And then guess what? You're off attacking somebody else's website. And there, if you are a podcast listener, there's a good Darknet Diaries episode on this. If you don't listen to Darknet Diaries, go check it out. There's a great episode with a guy named Rob Fuller, aka Mubix, and he talks about getting the wrong IP address on an assessment and attacking the wrong people and actually gaining access to that machine, which is a really, really big screw up on both parts, right? So you should always validate your targets. On top of this, when we're doing our web and our host, on the web side, we're going to look for subdomains, and we'll talk more about that as we get into it. But we can do that with Google, we can do that with Nmap, Sublister. There's so many different tools that we can use, and we'll cover some of the tools and how to do it. Get a little deep into that as well, especially as we get into the website of things. There's fingerprinting. We need to know what's running on a website or what's running on a host. What kind of services are out there? Are they running a web server? What's that web server? Is it IIS? Is it Apache? What version is it? Right? Are they running, what ports are open on their machines? Oh, they have FTP open. What version of FTP is open? So we need to fingerprint machines and kind of understand. But on the passive side, we're not touching any machine, right? So we're not going to be doing much scanning against a host. We just have to utilize what kind of information might already be out there. So if we go out to a website, it's on the border of active, but as long as we're not scanning it, in my book, it's still passive. So we will cover some of the passive/active side in this section, and then when we get into scanning, we'll get way more active with it. Lastly, we're going to hit heavy, especially in the beginning, on data breaches. Data breaches are the most common way when we're doing an external assessment that we get into networks. Absolutely by far. When we talk about data breaches, we're talking about breached incidents from the past that have leaked data. Again, these are like Home Depot, Equifax, LinkedIn, all kinds of breaches that are out there that have had credentials dumped, and then those credentials become available to us eventually, and we try to utilize those to gain access, or at least utilize the usernames to gain access. Nowadays, most of the time, there's not going to be an easy just scan, find something vulnerable, and exploit it on the external side of the house. So we're looking for these data breaches and this information that we can gather. And this is why information gathering and then enumeration and scanning, most important by far. The better scanning and enumeration that you can do and the better information gathering you can do, the better hacker you're going to be and the better you're going to be at your job. So take these first two sections really serious. So we're going to start in with identifying what our target's going to be for this part of the section. And then we're going to go ahead and start talking about data breaches and why they're important and go deeper into that. And then we'll go off some of these tools that you see here on this list and really dive into those. So I will look forward to seeing you in the next video when we identify our target and get some information gathering started. All right, before we begin doing our reconnaissance, we have to establish a client to attack. So for this course, we're going to be utilizing a client out of Bugcrowd. If you've never heard of Bugcrowd, Bugcrowd is a public bug bounty program. What that means is there are programs on the website that will allow you to attack them. And if you find a bug against the program, you're able to submit it and potentially get money for it. So you are able to hack these programs publicly as they are part of this program. Now, the program we're going to be attacking is Tesla. So Tesla is part of Bugcrowd. Now, please do note, please double check when you're watching this course, as some time may have passed. Tesla might no longer be part of this bug bounty program. So it's very critical to make sure that you are still within scope before you attack. If for some reason Tesla is no longer in scope, just go ahead and pick a new client and do information gathering on them. You don't have to pick Tesla when we're doing this. You can just do it to follow along with me, but you're also welcome to pick any program you want. So if you go to bugcrowd.com and we go to programs, I will show you where Tesla exists. Now you can see here that they have all different types of programs in here. And if I were to scroll down and continuously, I could find more and more and more. There are hundreds of programs involved, all kinds of names, DigitalOcean, Okta, really big names, Pinterest, Atlassian, anything that you can imagine probably has a bug program if it's reputable, okay? Any of the big names most likely have a bug program, especially if they're reputable. So here you can see what's based on reward, what's based on charity, and what's based on points only. that's how the bug bounties are rewarded. Some of them are not all cash. Some of them are just for points and for kudos, and the other ones are for charity. I'm gonna go ahead and just search Tesla. And when I do that, you can see here that Tesla comes up. Now, this is your first lesson into rules of engagement. And we're gonna talk about rules of engagement later, but it's super important to read the program details that you see here. And what we really need to do is we need to scroll through and make sure that we stay in scope when we're doing this. So we have a wildcard here. So this means that any subdomain inside of Tesla.com is fair game, Tesla.cn, Tesla Motors, etc. What is more important is that we stay within this out of scope. So we don't want to attack shop.eu.teslamotors.com or energysupport.tesla.com. It says you can report vulnerabilities to Bug Bounty for this one, any domains from acquisitions, such as Maxwell. So we have to stay within Tesla. And there's a few more sites. We're not going to worry too much about that. When we get into the web app portion of the course, we're going to talk about way more detail on enumerating web applications and go into that. So for now, what we're going to do is we're just going to focus on information gathering. What kind of information can we gather from this client? So again, I'm setting my target to Tesla. If you pick another Tesla or another client, just make sure you stay in scope of that client. So from here, we're going to move on to our first video and get our information gathering started. Welcome to the email OSINT section. We're going to talk about discovering email addresses. And this is something that I do on a weekly basis. So I'm going to show you the most common tools that I use to actually look up email addresses and try to find people, and what you can do to kind of verify email addresses. So I'll show you some of my favorite tools and concepts. And this is something that I do because not only for OSINT and doing it for investigative type work, but think about sales. If I'm trying to find a lead or I'm trying to find multiple leads within an organization, I have to figure out where the emails are, who the people I'm trying to email are. So maybe I'll Google them and say, who is the CISO or Chief Information Security Officer for this company? And I might find that it's Bob Jones. And we go look up Bob Jones and we say, okay, well, how do I get Bob Jones's contact information? Can I find it via Google? Maybe it's out there in the public, but maybe we have to dig a little deeper. Maybe we have to kind of do some guesstimation and see if we can figure it out. So that's what we're going to do today is look at the email addresses, formats, and try to determine if we can find some emails. So let's go ahead and move over to the Kali Linux machine that I've got. And the first website is one of my favorites. So hunter.io, you just come to hunter.io. You get like 50 or 100 free searches a month. I don't remember what it is. It's a fair amount. You can come here and basically just type in a company name. So like say I want to type in TCM Security, TCM-sec, and you can see TCM Security here. We get one result on the email address. So we'll click it and see what happens here. And looks like we have like an info@tcm-sec.com. It tells us, hey, there's 5 sources that identify this. So we see tcm-sec.com. There's an about, blogs. This is where they're finding it, okay? A better example, maybe something that has more users, like Tesla. Tesla has 468 users. If we come in here and we look, well, we can see that they have a pattern identified here. So their pattern they're identifying is first initial, last name at tesla.com. And that's really what we want to see. And then we can gather email addresses here if we want. But say like we knew Bob Jones, again, going back to that example, Bob Jones. So maybe Bob Jones works at Tesla. Maybe his email would be bjones@tesla.com. So it's something to think about. Now we can sign up and get actual information here. You should be able to sign up with a Gmail account. Sometimes this does not work depending on the country that you are in. So be cognizant, you might have to use a different email address, but I just tried signing up with a Gmail account that I have on here and it worked just fine. So I'm going to go ahead and try to log in. I'm going to sign in with Google with what's already here and just now I'm logged in. So we can go back now and try searching Tesla again, and you'll see that the results actually come back. So we get information here now. Let me make this a little bit bigger. We get information as to, okay, here's the vice president. This is the vice president's email address. Project development manager. Maybe you want to talk to somebody in human resources. So you can click here and go to human resources. And then here are the different human resources emails that are here. So, and then the sources that they found these email addresses. So this isn't a particular person in HR, but it's still human resources email addresses. So this looks like it's probably for Hong Kong. This is for Berlin. This is Gigafactory. So they have different email addresses based on where they are. Now, if you looked up TCM security here, you're really not going to find much on us because we don't have a ton of email addresses out there, but I think that we can find more in other ways. Now, so we only get so many usages here. We'll just keep thinking about this as we move forward. So Hunter.io, great resource. They have plugins if you want them. I think it's a fantastic place to look. Phonebook.cz is the next resource I want to show you. This one is fantastic. Let's start with tcm-sec.com and see. So we're going to go tcm-sec.com and we're going to search email addresses here. So they do domains and URLs as well, which I think is awesome. But let's just search for email address, see if anything comes back. No results. Okay, that's okay. Let's try Tesla and see what comes back there. Okay, a lot more. So we get quite a few email addresses. We could see Elon Musk all over the place. We got Elon-Musk, Elon, we've got eMusk over here, and we get a ton of emails. Look at this. So what's nice about this is we can sit here and try to identify what the possible email addresses are. So again, first initial last name looks like it's showing up quite a bit. Outside of maybe like the Elon Musks of the world, we're getting a bunch of mostly first initial last names in here. So I think that's pretty spot on with this. The other thing that we can do is we could utilize this list. Say we're trying to do something called credential stuffing, which we'll talk about in the next section, actually, when we talk about breach credentials. But say we're trying to gather a bunch of usernames and test and see if we can log in with those usernames anywhere. Or maybe password spraying, not so much the credential stuffing, but password spraying, where we take all these usernames and we just throw it at a login form and say, hey, summer 2020 exclamation point, see if that logs into any of these accounts. And you would be surprised. It happens quite a bit. So this is valuable information, even if we don't know exactly. Maybe we're not just hunting for one email. Maybe we're hunting for an entire domain. This is a great way to get free entire domains with a quick copy and paste capability. Like we have the Tesla here, we can export the CSV from hunter.io, but you only get so many results that you can export into a CSV. Here you get a bunch. There's no guarantee these are all valid, but it's still information. Information is what we want. This is all we're trying to gather, is as much information as possible. So these are all potential email addresses for tesla.com. I think it's a great resource. Now, we could also use something like Voila Nobear. Now, this one, you can get 50 more leads for free. I'm not going to show you. It's the same kind of deal as hunter.io. They're showing you how to utilize it here. Basically, you can just search for people and see to try to find their email addresses. There is one I want to show you that I do use and I have quite a bit of success with, and that is called Clearbit. And Clearbit has to be used in Chrome. So I'm going to bring up this here. Clearbit has to be used in Chrome. So you can download the Chrome extension for Clearbit. And all you would have to do is go to Google. Let me log in really quick. And then I'm going to just select the free account. We get so many searches, 100 emails a month. So basically, you're going to search for Clearbit Connect, and you would just say, hey, Clearbit Connect. I'll put a link down below, by the way. But Clearbit Connect is awesome. You'll see why here in a second once I authorize this. Okay, we're going to come down here, acknowledge, probably give out our firstborn. And then now we're going to say, hey, I want to find emails. And here's all different kinds of things that we can sit here and search for. You can see TCM Securities in here. These are some searches that I've done. These aren't any clients of mine. These are just searches that I've done in the past, maybe looking for information or looking for possible leads or anything. So If I come in here and I say, hey, I want to look for TCM security, you could type that in. I'm going to just click on TCM security. And look what it discovered that the others didn't. It discovered me. Okay, and if I click on me, look, it says heat.tcm-sec.com. Where did that come from? And then look, it has my LinkedIn right here as well. That's amazing. That's awesome. And it says here, you can email Heath. Just click this button. And then it's also got Rizwan. Rizwan's on my sales team. Look, it's got Rizwan at tcm-sec.com. What does that tell you? That tells you that we're using a first name basis for our email addresses. It's awesome. Now let's come in here and maybe we want to look at Tesla. Maybe let's try Tesla one more time. Maybe we're looking for the CISO of Tesla if Tesla has a CISO. You could come in here and look, like Elon Musk is right here, obviously CEO, but you could come in here and maybe go by role, and they have different roles in here. So CEO, let's see if we can find any sort of CISO. I don't see one, but I do see information technology. So maybe we can find somebody in the information technology department or IT department. And then here we go. We've got quite a few IT people. Here's a CIO. This could be somebody of interest that we might want to reach out to. And we could just scroll through this list and find people. So say we want to reach out to the CIO, just click on this. We get first initial last name, just like we thought we would. We get this person's LinkedIn page. We get their location, website. This is awesome. Awesome, awesome. So I typically will start with a Google search. If I'm trying to hunt something down, I will start with a Google search. I will say, who is in this role at this company? If I'm looking for a specific person at a company, then I will go to phonebook.cz or hunter.io, try to identify the formatting of the email, and then try to find that person or guesstimate that. Once we get to that point, I try not to burn through these Clearbits unless I need to, but Clearbit is very good at identifying this. Once we get to that point, we can take this email, say like this email, or we'll even try a different email. I'll show you a couple. But we could take this and we can go try to verify this. So there is a website called Email Hippo. You can go to tools.verifyemailaddress.io. And all you have to do is type in an email address here. Sometimes you can get false positives if they're good or bad. Here, I typed in this email address a couple times and just got a bad result. This is an email address that does not exist. Now, let's try an email address that we saw, info@tcm-sec.com. See if it works. Result is okay. So it says, yeah, this email address works. So we're verifying that this is up. So say that you get somebody and you see that they have a potential email address, you can come here and try to verify it first and see if it works before you go fire off an email. You don't even have to fire off an email. You don't have to do anything or interact. So this is the benefit. Like if you're from a sales perspective and you're doing OSINT here, this is the benefit of not having to email, waste your time, get it rejected. You can come in here and just validate. If you're doing an investigation, you don't want to interact with the person or company that you're investigating. You want to come in here and just verify without any interaction. This is the way to do it. Same thing with this website here, emailchecker.net/validate. email-checker.net/validate. Say, hey, checking the email. I put the same email address here. You could see it says bad. We could try again with info@tcm-sec.com and see if that works. And it says okay. So again, this is doing a great job. There are possibilities of false positives. There are so many searches that you can do per month on these, I do believe. They have APIs, which is nice if you want to automate this or script this out. But I think this is fantastic. This is great stuff. Now, there are plenty of other ways to verify email addresses. In the next section, we'll talk about that even more as we talk about breach data. Because if somebody shows up in a data breach, guess what? That email address has been used in the past. If you look at something like a Have I Been Pwned, which we'll talk about in the next section, and they show up, guess what? That person's email address has existed. So we're trying to verify if an email address exists, who that address might belong to, etc. Now, this has been from a business perspective. Some of this hunting down of emails may be more difficult to do if you're trying to find a specific individual. That's where breach data comes into play in a lot of this research. And what I'm going to show you in the next section, we'll try to hunt down individuals with maybe having loose pieces of information like a name or a username or something along those lines. Breach data can come in handy very, very well. So this is kind of scratching the surface. Now there's one last thing I want to show you, one last little tip and trick. Do not underestimate forgot passwords. Do not underestimate them. Let's go to Google, for example. Right now, I am logging in under an account that is please don't hack me, sir, please. So it's please don't hack me, sir, PLZ, I do believe. I'm going to go ahead and try hitting next on that. Okay, so first of all, it said, hey, welcome. And what does this mean? This means that we have a valid account here. That's great. This is validating that this Gmail account exists. Here's something else. We can use this to tie to potentially another account or help validate. Say we know that this email belongs to somebody that's harassing somebody else. We don't know who this person is. They're using this spoofed email, but maybe we have a hunch or maybe we don't. Maybe we just want to try to get more data. You can come to forgot password and it's going to say, what's the last password you remember using? I don't know. Let's try another way. You come down here and it says, hey, let me make this bigger. Google will send a verification code to H. And it says, look, it shows you the rest of the digits here, and then at TC here. That would give you a pretty good indication if you're tracking who your subject is, that this email could tie to somebody else. Look, this is Heath at tcm-sec.com. Okay, so this email belongs to me. This is tying back to me. Now you have another point here. So if you knew about this email address, and now you have the link, the connection to guarantee that this person, this is evidence right here. Say you were doing something, which we'll learn about again in the next section, where you're looking through breach data, you find a username that matches this email address and also matches this email address, but people can reuse usernames. There could be multiple people who use the same username. So you need to verify or some link. This would be a proof of a link between those, a pretty strong proof if you ask me. If you can say, hey, I identified 2 email addresses with the same username, I did an account recovery, came in here and saw that this had this same first character and first domain name, I think that's a pretty strong correlation. So things to think about, wheels to be spinning. Try to identify email addresses in any way possible. We'll cover this more in depth in the next section. And I'm really excited because password hunting is one of my favorite things. So let's go ahead and move on to the next section when we talk about password OSINT. Okay, so I would like you to go out to github.com. And then once you're there, go ahead and just do a /h Maverick Adams. HMAVERICK Adams, and hit enter. And you can see me in my snazzy photo here. But what we're after is, I want to show you a tool that I wrote called Breach Parse, and we're going to walk through what it does. Now go ahead and click on Breach Parse, and you're going to see a bash script here and a little bit of a description. So you do not need to download this. Let me preface with what we're doing here. This magnet link, you're going to need a torrent, some sort of uTorrent or BitTorrent, and you'll need to download this. And it's also something along the lines of 44 gigabytes extracted. It's a huge file. So you don't have to do this. You can just watch and follow along. You are more than welcome to install this on your machine. I'm going to show you what it looks like. So I'm going to go out to my applications and my files here. And then I have put this into my opt folder. So if you come into opt here, and then I've got breach parse. If you come into this breach compilation folder, which is what we'll download, you're going to see that we have data here. Okay, so this data has a bunch of different data. It's got emails starting with 0, 1, 2, 3, 4, all these different ones. What's living inside of this is, if we can display it, is emails and passwords. Now you see these ones have weird symbols inside the emails, but there's a bunch of emails and passwords in here, like somebody at yahoo.com and their password is 123456. Well, these passwords are coming from credential dumps. So we talked about it earlier about thinking about the Equifax or the LinkedIn breach or Home Depot, all these big breaches that happen, credentials get dumped out. And guess what? They show up on the dark web, and eventually they show up in these lists. So we utilize these lists, and we've got, if you click into this, just hundreds of files here, and again, 44 gigabytes. So what I did was I built a little tool that can search through this data and pull down names. So we could take a quick look at the tool and what it does. But basically what it does is you just put in the syntax, you search for something like @tesla.com, and then you specify, tesla.txt. And it's going to search through all of these files for @tesla.com. If you're more interested in the code behind it, you're more than welcome to read the code in here and see if some of the items that we've covered already with the bash scripting and the Python scripting kind of ring a bell. So what we're going to do is I'm going to come ahead and go into the terminal and make it a little bigger. And then I'm just going to change into that op folder breach parse. I'm going to run breach parse. So breach parse here. And what we're going to do is I'm just going to say @tesla.com and then tesla.txt, and that's going to run. So again, you do not have to install this. This is only for visual purposes. I'm going to show you in the next video another way to do this. So this is going to run through. It's going to take a minute here, and it's going to grab everybody's username and password that says tesla.com and the username, and then it's going to have all the passwords. And we're going to be able to decipher things from this. So I'm going to let this run, and as soon as it's done, I'll come back and we'll talk about the results. Okay, the results are back. So this breaks it down into 3 files. There is it's cat Tesla. There is a master, passwords, and user. So the master has the username and password, and then the users file has the users, passwords has the passwords. So I'm gonna actually gedit the Tesla master.txt, and let's take a look at this. So from here, we don't have a big list, surprisingly, for a company the size of Tesla. So what happens is people utilize their work credentials or their work emails, and they log into websites and probably shouldn't be using their work emails for, and we just use it to our advantage. So what we're after not only these usernames, but we're after these passwords as well. So we see these usernames and we see these passwords, and I like to look for repeat offenders. I like to look for the syntax as well. Remember, we had first initial last name, but we see first name dot last name here. We see possibly, just a single name. There are different types of things in here. So Nick @tesla.com as well. So, it's changed up. I think nowadays it is first initial last name, but maybe in the past they used first name dot last name and then moved to an easier format, or vice versa. They started first initial last name, they got too big, then they had to do first name dot last name. But again, what we're after here is potential repeat offenders. So look at this shark @tesla.com. It got popped twice. And the password is very, very, very similar. So if I were to attack tesla.com through a login interface, I might spray this username with this password and this password. That's what we call credential stuffing, because we already know the passwords. And then I might make some modification of capitalized letters and non-capitalized letters with DADE, because 907 and 814 appear to be consistent. So I would alternate capitals and non-capitals here in lowercase and just see maybe if something sticks. So this is something that's interesting. This user down here, 12345, 12345 star, probably not going to get in with that on a company like Tesla, but you never know. But this is what we would do. We would take the usernames and we would throw these passwords at it, and that's called credential stuffing. And then we would take these usernames and all the known usernames, and we would spray passwords at them, like fall 2019, like we talked about in the last video. That's password spraying. So this is an important and very, very critical part of information gathering, is gathering these usernames and these credentials. Right off the bat, you want to identify those with your targets. So this is kind of what it looks like. This is what I do during every assessment, and hopefully that makes sense and that works into it. In the next video, we're going to go ahead and just show another method and start thinking again about these credentials and how they can be utilized. And then we'll do some other information gathering as we move on and learn some techniques and how we can get information on a client. So I'll see you over in the next video. Okay, let's talk about hunting breach credentials and let's get hands on. Now, before we get started, I know I stressed this in the beginning of the course. I'm going to stress this again. What I'm going to show you here could change. Now, I released a course about a year ago, which was on ethical hacking. We talked about breach credentials, and I utilized a website called WeLeakInfo. WeLeakInfo was then eventually shut down, and I got all kinds of emails saying, hey, this is shut down. I don't know what to do. There's more out there, okay? There's always more out there. What I'm showing you is the methodology. I could show you on a specific website, which I'm going to do. That website could go down tomorrow. We never know. But what you need to retain is the thought process and the methodology behind what's about to happen. From there, you could take that and utilize it elsewhere. So if a website does go down, you still have the same thoughts, why you're doing it, and why you're thinking about it. So let's go ahead and move over to a website now. So I want to take you to a website called Dhash. Now this is dhash.com. I do not expect you to be able to follow along at this point because this costs money. Okay, it's $5 for a week. It's $150 for a year. This is only, it used to take credit card. They only now take Bitcoin, I do believe, or some sort of cryptocurrency. Absolutely worth it, in my opinion. Even get a week. Get a week, see if you like it. It's amazing. There's going to be tools I show you later on in the course that will go through and we can do it locally, like the one I just ran in the last video. I ran BreachParse, right? This is something that I put together and set up, and it's free, but the database isn't maintained. It's a slow search. I don't get the results back as instantly, and I can't tie it to as many data points as a website like this can. I think this website's great. Now let's talk about what Dhash can do now that I'm logged in. We have the ability to search by, let me make this a little bit bigger. We have the ability to search by email, username, IP address, name, address, phone number, VIN. Okay, think about this. Say we know a email address. Okay, we know an email address. Say it's Bob at Tesla.com. We're not going to search this yet. We take Bob, and we know Bob, it has an account, and we're looking for him. We search him. Bob shows up. And we see Bob shows up, and we see maybe his name, like Bob Jones or something like that, shows up. Maybe something that he's been leaked in has his address. Or maybe there was an IP address tied to the client you're looking for or the person you're looking for. This can all be identified. What if Bob has a username? It's like Bob Rocks 123. Okay, well, we can search that username in here and see if that username has repeated itself at all, which is great. We could search by password. So say Bob's password was BobRocks123. We could search that password, and if it's unique enough, then maybe we can actually do some advanced searching. Like if we go back to the example from last time, like this last video, we saw this 907DADE814. We could put that into a search engine and see if that comes back to something else. Maybe that comes back to a user that is not at a Tesla.com, but maybe it's like Bob at gmail.com. And then guess what? Now we have Bob's personal account, or now we have Bob tied to another email account, especially if we search by name or something that we can tie them together. We need to start being able to relate other accounts to each other. We can do that with hashing. We can do that with passwords. There's a lot of things that we can do, and we want to start tying this together. As a real world example, when I am looking at an organization and I'm doing research on hashing, or I'm doing research on breach credentials, I'm trying to think, okay, first, if my client is Tesla.com, I might come in here and search at Tesla.com, and I might come see how many results are in here. Let's see what happens. Okay, here's George at Tesla.com. George has been in a shared data, so there's no actual any details here besides a potential username, a name, email. Okay, same thing with safety. We'd have to scroll down and see if we can find something that, okay, here's Adobe. Now, Adobe will have there's actually a Bob at Tesla. Bob at Tesla has a hash password here. Okay, so now we could say, well, first of all, we can go see if we can figure out what this hash is, which we'll talk about in a second. We can also go and say, okay, Bob, does Bob exist anywhere else? Does this hash exist anywhere else on this website? Can we tie it to another account that maybe, even if we don't crack the password, then we can say, okay,
this ties to bob@gmail.com. So like I would note this down and I would take this and copy it. So from a real world example, I would take all the data that I see on this website. I would collect all of the passwords, all of the usernames, everything. So like Tesla 9, all of this. I want to know what the passwords are. I want to know who the people are. I want to know all the data. Because if I could start finding patterns, if I could start putting things together, maybe I can even relate these back to their personal email accounts like we're talking about. And then I could see password patterns there or other passwords and just start tying this down. Because my goal is to break into an organization. If I'm doing a pen test, my goal is to break into an organization. So I'm going to take that data, and if I can find other passwords related to a personal account, I'm not going to go attempt to break into a personal account, but I will take that data and I will put it together and maybe try to break into their work email account with those passwords of that information. This can tie to an investigation as well. If you're hunting down an individual, you're trying to tie them to other accounts, this is incredibly useful. If you can find their data in a breach database and have a password, and that password's unique, you can search it, maybe find them somewhere else. You find an IP address, you find a name. There are often IP addresses in here, which we can tie to a location possibly. And see, here's that 9078 or DADE 814. We could take this and maybe search it and see if it comes back anything. Who knows? Shark at Tesla. Okay. Shark at mail.ru. Look, this is a new email address. We didn't know about this one before. And look, it does us a favor. We searched DADE, but here's the capitalize. We didn't search for capitalize. We're not searching specific. Okay, and now we're getting more information. Look, here's one for Dropbox. Okay, so it tells you where this is coming from and how you can tie it in. If we can get any sort of name out of this, any sort of anything, that would be amazing. We can get a person's name or IP address and we can start tying them down. But when you're doing different searches like this, you need to start almost, like in the investigations where they have like the red yarn and it's going from one pinpoint to another. You kind of have to zigzag that back and forth and really try to tie this down. And you'll see that when we get into reporting, how you might take one individual and really just see like a password tied to an account, tied to this. And this was the exact methodology that we took to get to that point. Because when you write a report, you want to make sure that the investigative person, or say you're handing off to the police or whatever, you want to make sure that the person that is doing what you did, or they can replicate what you did with ease, and there's no question about it. So this is some of the searching that we can do. Now, if we come to dehashed, again, we can come here and we can search by email, username, name, anything. So you can put your name in here. I mean, if you want to search on here, I think it's great. You can come through here and just search for your name. Let's go back. Let's search Tesla again. I saw a hash in there. The Adobe hashes are kind of interesting. They're not the easiest to pick up, but let's see. Let's find this Adobe hash. So let's say we get a hash like this. We could try to identify what this hash is. We can try to crack this hash. We can see if it's been cracked somewhere else. This hash, as of right now, we have no idea. But we know bob@tesla.com. We can maybe paste this in here first of all and see if it ties back to anything. And there's 22 results back. I would probably be looking for somebody that has this password with the name of Bob. It's probably not going to be like a Brett or a Michael. We might want to see if we can find another account somewhere else, but these are all tying down to a hash from Adobe. So depending on how they were hashing this data, we might not find anything else of interest. But you could see all the things here, all the different opportunities that are here for us to just do research and tie down information. Now we can go to a website called hashes.org. And if we come here, we have the capability to actually try to search for this hash. So we could search hashes and see if we can find it. So you can come in here and just paste it. And again, it doesn't do a great job, in my opinion, with the Adobe hashes. Sometimes they crack, but a lot of times it says it can't find them. Oops, there we go. Let's try hitting a search here. Okay, so it says not a valid hash. Now, if you put this into Google as a search, you can see it didn't come back with anything either. So we want to make sure that when we're searching this, we try all options. There is an Adobe database that if you do put in a hash and it does show up, there's a GitHub Adobe database that will actually show up here. So with that being said, this is kind of what I want you to start thinking about when we're hunting down breach credentials. How can I take a person or company that I'm looking into? So if you have a company, you can just go at companyname.com or .net or whatever it is, search in here, see how they show up. If you have a person, maybe a personal email account, if you can find that person, if you know their email account, you come in here and say bob@gmail.com. Maybe you don't know what their email address is. Then maybe you come here to the main page, you go, okay, I'm going to look for a name. I'm going to look for Bob Jones and search for that. And then you start taking this and trying to find the patterns. If you know Bob lives somewhere, maybe you could find an address for Bob, or maybe you know Bob lives in like Arizona. You could search Bob Jones and see if Bob shows up, and then kind of take it from there. And there is some search operators that you can utilize. You can see Bob Jones is taking forever. You can put this in quotations and search it again, and kind of narrow down your results here. So if we click on this, you could see like, here's a name of, we got a lot of results, but here's the name of Bob Jones. This is a very common name. So, but you could see like, if we're trying to look this down, we can start searching and adding operators in here and trying to see if we can figure out to tie a username or something to them. So again, get your wheels spinning. Don't rely on just dehashed, but just rely on thinking about this. This is the thing you should be thinking about. Again, dehash could go down tomorrow. But if you're thinking about it in the way that the credentials and the information can be interwoven, remember that red yarn again, that's really what I want you to take away from this. So we're going to do another video on this. I'm going to show you some more, I guess, tools that are out there and some other things that you can do, offer alternatives to this, and then we'll wrap up this section. So I'll catch you over in the next video.